Hi, welcome to a new SimplyMaya tutorial. In this tutorial we're going to do an introduction to modeling in Maya with an emphasis on topology and edge flow. Now we're going to concentrate on what makes a model good within this tutorial. So what makes it quadratic geometry, why edge flow and topology are important. And we're going to end up at the end of it with this little car here. Now this little car is actually built out of individual Lego bricks, which I can show you with this basic build animation we've got. So this is just showing you all the bricks that go into this particular build. Now we're going to look at quite a few of these bricks because Lego looks deceptively simple to model, however it's not. To get the topology right, to make sure you can use it further on down your pipeline, to make sure it renders well. Bad models won't render well, they won't catch the light in the right way. If the topology is not correct, you'll get banding. So here's a couple of renders, and these were actually very simple to render because of the way that this model was created. Now that's not always the case. Sometimes you can have something that looks fantastic in the viewport or looks good in the viewport and won't render. You end up without being able to catch highlights along edges. You end up with curves that aren't smooth. You end up with all sorts of problems, and that's really what this tutorial is about. It's about addressing those problems and why they come up. So, we have our little car here, but really it's just an excuse for me to show you various different modeling techniques. So we'll look at starting out with box modeling. We'll look at the topology of that, how to turn it into quads, how to avoid bad surfaces, how to smooth the model correctly so you get this nice highlight along the edges. We'll look at also using some NURBS curves. We'll look at starting off the model from a polygon plane. We'll do a variety of different modeling techniques within this to get the various bricks, and Lego is kind of perfect for this. Now, if you aren't brand new to Maya but are struggling with modeling, this is going to be a great tutorial for you as well. There is two parts at the beginning of the tutorial that cover basic topology and movement around the interface in Maya. So if you're perhaps a little more au fait with Maya, then you can skip those first two parts, but the rest should be very relevant. We'll be making some quite complicated shapes as one object as well to get the smoothing right. So if we take a look at this one, you can see that it's all one object here. It hasn't been simply combined, it's been properly topologized, so it comes out looking nice. Also in the renders you might notice here that there's a big pile of Lego bricks behind my car. Well, because of the way these were modeled, it was absolutely no problem to just drop the whole pile with bullet physics. Took a couple of minutes, whereas if they'd been modeled incorrectly, that wouldn't have been possible. So there are a lot of considerations when you're modeling in Maya, and it's important to get them right from the start. I mean, I can give you a very good example if you are perhaps new to the software and you haven't really played around with topology and what it means yet. Let me just give you a good example. So here we have three Lego bricks, green, red and blue. And they appear on the surface of it in the viewport to be absolutely identical. So one of these bricks, the red one, took me about 5 minutes, I think, to get right, to get the topology right, to get the edges right, and the other two were done in different ways, but they took 30 seconds. So let's render them and see why I spent the extra time here. So I'm just going to hit the render button and we'll let Arnold render this in. Okay, the red brick's looking fairly nice. It's got and then of course you've got the blue and the green brick, which are an absolute disaster, but if we refer to our viewport, they look absolutely fine. So modeling is more than just getting it to look fine in this one view, and it's actually more than getting it to look fine in this view as well. I can get a model that looks like this, has nice crisp edges in the render view and in the modeling view, and then it simply won't be any use for simulation. It wouldn't be any use for animation, things like this. So I designed this beginner's course to cover the basic fundamentals of why a modeler at a studio would spend 2 days perhaps modeling a shape that looks like it could be done in half an hour. There's a lot more goes on behind the scenes than a lot of people realize when they first start, and I hope to address that, and I hope you find this extremely interesting. So thanks for watching this introduction. Sorry it went on a bit long, but there is quite a bit to cover in this tutorial, and I very much hope you enjoy it. Thanks for watching. Hi, welcome to this brand new SimplyMaya tutorial. Now in this tutorial we're going to concentrate on the very basics of Maya, but we're going to do it in such a way as to give you a grounding and understanding of how to work as part of a professional environment, a studio environment. So we're going to concentrate on good topology, we'll concentrate on organizing your scene file, and during the course of this we're going to take a look at Maya as a whole, right through from curves and surfaces, polygons. We'll look at lighting, UVing, texturing, basically what you need to go from the blank screen we have in front of us to the finished result that you saw on our introduction video. Now, we picked Lego for this because it's deceptively simple when you look at it, but to get good topology on Lego is not that easy. And getting good topology is one of the things that we're really going to focus on during this course. There's so many people are capable of modeling something that on the surface of it looks quite nice, but will be absolutely useless in a production environment. So we really are going to concentrate on what makes a model good in terms of its topology, why you need to do it this way. We're going to focus on the basics, but to give you a foundation that you can then build on to go ahead and start making much more complicated stuff. So this first part is just going to be a basic how to navigate in Maya, the interface, the menus. So if you are at all au fait with Maya, if you are not using it for the first time, if you've already know how to navigate, you can skip straight to part 2. For those of you that are just opening Maya for maybe the first time, or you have a little bit of knowledge but you'd like to improve on that, well, I'm going to go through the very basics here. So to start off with, how we navigate around. Now if you push Alt and the Alt key on the keyboard and hold the left mouse button down, you will rotate around the view. As you can see, this is the grid here. It's a fixed object. It won't render out. So this won't be visible when you start to render your shots, i.e. when you go from this view to a rendered nice final picture, which we'll get into later. So this won't be visible. It's basically a virtual object to give you some reference when you're moving around. So Alt and left mouse button will move you around this. Alt and middle mouse button will pan you around this, and Alt and right mouse button will zoom you in and out. Now a word on this, because I continuously see people doing this, and it should be avoided. So if you're just learning this now, this is the better way to do it. If I bring in a polygon object, which I can create under the polygon shelf, so this is a polygon primitive, in this case a cube, and we want to zoom in on this. Now a lot of people would just use the middle mouse button, and you can see that clicks down in increments like so and allows me to zoom in and out. Now it's very natural to do it this way because we're all used to scrolling down web pages and whatnot with the middle mouse button. So scroll up, scroll down. Herein lies the problem with this method, however. Maya keeps a history of its camera movements. So if I am, let's say, modeling on this cube, and I spin the viewport around to here and start modeling on this side, and I want to jump back to where I previously was, well, Maya will keep a history of those movements that I can access using the left and right brackets. So if I hit the bracket here, you'll see I jump back to where I previously was, so I can jump backwards and forwards. But if you use the middle mouse button to zoom in and out, let's say I zoom out all the way over here, because this is done in clicked increments with the mouse button, in order to zoom back into my original view, I would have to go through a ton of levels of camera movement, and this would become extremely annoying. So it's better for you to get in the habit of hitting Alt and the right mouse button and just zooming in and out by moving the mouse backwards and forwards. This way, if I am here and I zoom right the way out here and I want to jump back to the previous position, it's just one jump now. So it doesn't have that stepped increment thing that happens when you use the middle mouse button. So if you have been using the middle mouse button to zoom, get out of that habit. It will save you time later on down the road. So that's the basics of navigating. So Alt, left button, rotate, middle button, pan around, right button, zoom in and out, say, and avoid using the mouse wheel. So, basics of navigation. Now, that's moving the camera is what we're doing here. If you want to move the actual object itself, so in this case this polygon cube, as you can see, it's come in directly in the center of the scene. So it's bisecting the floor, because you can think of this grid as a kind of virtual ground. So if I click my cube, you'll see it highlights the wireframe on it, and press W, that will allow me to move the cube around. So these are our axes in Maya. We've got Y, Z, and X here. And you can see that down here denoted by this little thing. So we know X is in this direction, Z is in this direction, and Y is generally up in Maya. So we can move this by grabbing one of these handles here, clicking on it and moving it about, and that will only allow us to move in one axis. It doesn't matter what I do with the mouse here, it's only going to move in that axis. Or I can grab this one, which will allow me to move it in this axis, or this one, which will allow me to move it in this axis. If you just want a free move, just click in the middle, and then you can move it about wherever you want. This is generally not that useful a thing. Generally when you're modeling, you would prefer to use the axes. It's more precise. With this one, it's actually very difficult to determine where you're going to put it. So that's moving it about. If you hit E, this will allow you to rotate it. So we can rotate it like so, again just using the axes. Now there's one other thing we can do with it, which is scale it. So if we press R, you can again scale it in its axis, or uniformly scale it. So that's the basics of moving the camera about and moving the object about. Now let's go ahead and bring in another cube. So I just selected that one and hit delete on the keyboard, and then let's bring in another one. And now let's talk about how we do this in a more controlled fashion. So let's say we wanted to move this, but we didn't want to move it just like so. We wanted to let's say snap it to this next grid point. Well, up here on this little menu bar is your snap. So snap to grids, snap to curves, snap to points, so on and so forth. We'll be taking a look at snapping throughout the tutorial, but right now, just for the basics, if you hit snap to grid, you'll see the center of our pivot goes from a square to a circle, which means snapping is on, and then as I snap this, I can snap it backwards and forwards to the grid. So this is quite useful when you need to line objects up directly with each other, and it becomes useful later on when we're dealing with actual modeling and we need to snap our vertex or edges or faces to each other. So let's turn that off. Another way to do an incremental movement is hold J and click. Keep it held. Press and hold J, and this will allow you to move in increments, not along a grid, but along a predetermined number. So if I do that with rotate and I hold J, this is especially useful if I'm looking to rotate this thing exactly 90 degrees, then doing it this way, it can become quite tricky. I'm never going to get it accurate. But if I hold J down, so press and hold J, you'll see that this snaps now in increments, and it becomes much easier to adjust it. Now if we want to check that that's perfectly flat, if you push the space bar or hit this button here, the one that has 4 views on it, this will now allow us to have this perspective view, which we can freely tumble and move about in, but it will also allow us to have a side view, a front view, and a top view, and it tells you which axis these are. So this is the view from Z, the view from X, and the view from Y. With my object selected, if I hit F, that will zoom it in so it fills up the screen, and then of course you can zoom it out a bit by Alt and the right mouse button. So you'll notice that I can't tumble these views. If I try, I get a warning on the bottom left that says tumble tool. Won't do it. You'll see it's got a little X there because these are orthographic views. This is always going to be perfectly the top view, perfectly the front view, and perfectly the side view, which comes in very handy. Let's say we wanted to manipulate this thing so it was lying exactly on our virtual ground here. We can hit W to move it and move it up until it's exactly at the point of the virtual ground, which in this view becomes a tad more difficult. So we'll go into modeling and using these orthographic views as well as the perspective view, because they're all used quite extensively while modeling. Now, another way we can manipulate our cube here in terms of its direction is to go onto these side menus here. If we go to the channel box, you'll see that I have translate. Now, translate is its place in space, if you like. So let's reset the translate to 0. We'll reset everything here to 0. And you'll see that if I take the x-axis and move it this way, you'll see the translate moves in negative x, and if I move it positive x, it will move positive x, and again the same with y, up and down, and the same with z. So, oops, I've actually grabbed the center handle there, and the same with z. So to do a precise rotation, or in this case a precise movement in space, if I wanted this thing to move 10 units this way, so let's say 10 units in x, so if I wanted it exactly 10 units over here, I can just come in and type 10, and you'll see that that has moved 10 units on the grid. Now, I can do this with rotate, so if I wanted to rotate it 45 degrees, there we go, it's 45 degrees on the x-axis. So we get a diamond, as you would expect. 90 degrees will flip it completely over, 180, of course we'll turn it upside down. I think you get the point there. Now, so moving it back, again, of course we can just set it back to 0. So let's discuss Maya units. By default, you'll be working in centimeters, and you can set this to feet and inches, you can set it to meters. I would recommend that you get used to working in centimeters. It's just easier in the long run, and it's what most people use. So I know a lot of our American viewers will be used to working in feet and inches, and you can change that. You go up to Window, Settings, Preferences, and there is units here somewhere under settings, I think. So working units, linear, centimeter. We've also got here our frame rate, which we'll get into when we discuss animation, and our angular, which is set either to degrees or radians. Most of you would probably prefer degrees, and generally that's what it's always left at. And as you can see, you can inch, foot, yard, meter, centimeter, and millimeter. Now, I would strongly recommend you leave this at centimeter, even if you're more comfortable in feet and inches, simply because we're discussing good working practices here, and when you're working as part of a studio team, most studios will just set their working units to centimeters for the simple reason that if we were to take this object we'd created here in Maya and export it to Marvelous Designer or Krakatoa or any of the third-party things we use, ZBrush, Mudbox, most of the default working units are always going to be centimeters. So it can cause a lot of confusion when you're constantly swapping backwards and forwards between different units. So again, you can change it. My recommendation would be to get used to working in centimeters, and to be honest, when we're in Maya, we don't have to be millimeter or thousandths of an inch perfect. So the measurements aren't going to be that critical to you all of the time. So if you can get used to working in centimeters, again, would be my recommendation. So another thing that's very important in Maya is keeping an organized scene. So if we have let's see, a sphere here, and we can just move that out. By default, when you click it, it will be selected. And we move this one here. Now at the moment we've got simply two objects in our scene. So let's get a ground plane in as well. So here is a polygon plane, and we're going to zoom this up like so. Now at this point, because I've put my own ground in, I can actually turn the grid off should I want to, and that's here, grid. So off. Now I've got my own ground plane. Now you'll notice with these objects as well, they all come in with a different amount of geometry. This cube is very, very simple. This sphere has more geometry, and this ground plane comes in with all of this. Now you can change how much geometry an object has. So first off, let's move these so they sit nicely on the floor. And the easy way to do this is to press spacebar, go into one of the front or side views. We know our floor is along this thicker line, so let's select this sphere, and move it up until it sits on the floor, and do the same thing with the cube. Okay, now we have two objects that are sitting on the floor. So let's discuss this, why these have come in with different amounts of polygons on them, because this one obviously has 6 faces on it, as a dice would have. This one has 400 faces, and I can see this here. If you're not seeing this, you need to turn on the on-screen display. It's extremely useful to see how many faces, how many triangles, how many vertices you're dealing with. So this is very useful information that should be turned on by default. So I can see when I select my sphere, faces 400. If you're not seeing this, you'll need to go up to Display, Heads-Up Display, and turn on Poly Count. So if I flick that off, you'll see it's gone. Display, heads-up display, poly count. Now you should get into the habit. Oh, I've hit particles by accident, excuse me. So let's turn on poly count instead, and then turn off particles. But as you can see, there are more things you can turn on here, and more about that later. But for right now, let's just deal with this question of geometry. So 400 faces for this object, 100 faces for this object, and 6 faces for this object. Now, most of the time you'll want to start from a simple primitive. You really want to keep your geometry as simple and as neat and tidy as you possibly can. This way, if you're working as part of a pipeline, the next guy down the line won't get a big mess from you. And also, even for yourself, when you're modeling and you need to add more bits, the less polygons you're dealing with, the easier that's going to be. So if we look at this, why do these objects have different poly counts? Well, if you go to the channel box, and we select the sphere, for instance, you'll see here inputs polysphere. So if we click this, you'll see it has 20 axes in the this way around and 20 axes in the height. So if we change that to 10 and 10, you'll see it gets a lot less geometry. But there is going to be a point at where it can no longer make a sphere. If we changed it to 6 and 6, you'll see we're now starting to get something that's not completely spherical. So if we change it to 4 and 4, so there is a point of diminishing returns. Now there is a way to work with very low polygon geometry and still have it smoothed out, and we'll deal with that later. But for right now, let's just put this to 20 and 20 to get it back to its original shape. The same thing holds true of the cube. So most modeling in Maya is started out as a simple primitive object. So generally speaking, most modeling exercises, if you're modeling a head or a person or I don't know, a table, a chair, something like this, you'd start out from a box. There are certain occasions when you would start out from a polygon plane like this one, but generally you're going to be starting out from a cube a lot of the time, or a box. It's referred to as box modeling, and it's very common, and probably one of the most used starting points would be this cube. But it's going to be very difficult to manipulate this cube when it has 0 geometry on it. It only has 6 faces we can manipulate. So if I come in here, again, I've got subdivision width, height, and depth this time. So if I change that to 2, you'll see we subdivide this into many more faces. Now, basic objects are made up of faces, edges, and vertices. So we can change this view by right mouse button, edge, face, vertex, and that's what we're going to concentrate on right now. So the face would be the large face that we have here, and again, we can manipulate these in the same way as we would anything else. We can use W to move, E to rotate them, and R to even scale them in. So by this process of manipulation, we can start to form the basic shape of something. So that's faces. We can do the same thing with edges, which would obviously be the edges here. So again, I can scale this in, scale it down. Well, actually I can't scale it down in this case because it's already completely flat. Scale it inwards, and W to move it, and of course then E to rotate it, like so. So we can start the basic manipulation of a polygon object. Now, vertex would be the points that lie in between where the edges meet. So these can also be manipulated, of course, in the exact same way. Okay, so there you go. I have made abstract art, I guess you could call it. Right, but now in our scene, so now we know the basics of moving around our scene, the very basics of an edge, vertex and face, and the basics of why these objects come in with the geometry they do. We also know and now we need to know something about scene organization, because we've got our three objects here, but we have, polysphere 1, polycube 1, and polyplane 1. In this case that's okay, but as we start going down the process of modeling and creating more objects and getting more complicated scenes, this really needs to be organized, and you really need to get into the habit of doing this right when you start using Maya, because I've actually seen people fired from production offices for being unable to keep an organized workflow, and it's a serious problem when you're working in this industry. Somebody hands you a file that you're supposed to continue working with, and you've got sort of polycube 1, polycube 98, polytriangle 27. It becomes really difficult to work with and really confusing for everybody else. Not to mention your own workflow will be radically slowed down when you're trying to pick from hundreds of objects that are all called polycube 296, polysphere 4023. It's just not a good practice to get in. So in order to organize our scene here, we're going to bring in the outliner. So if you get up to Window, Outliner, you'll see here this little thing is a lifesaver. It will help you easily pick objects from the view, easily pick cameras to change, and it will also allow you to organize your work. So if we were to say want to name these things, so this is the ground, so just literally come in and name it ground. Okay, and we do that by double clicking on this, which then allows a name change. So we're going to call this well, whatever you want really. Now in a studio situation you would have a naming convention a lot of the time to work to, but for your own work try and give it a name that makes sense to you and would make sense to somebody else. So just sphere, and we'll call the cube cube. Now this is very, very simple organization, simply because we want to be able to look at this later on when we open it later, and this scene is so simple that it wasn't necessary. But that's the way you always start out thinking that it's not necessary, and then 6 hours later you've ended up in a huge mess. Now personally I like to dock the outliner, and the Maya interface is more than capable of docking these windows, like this one here is docked. So if you just take it left mouse and drag it over to the dock spot, you'll see the bar there goes blue and highlighted. We can dock the outliner over here. Now I always work in Maya with this outliner open. So a few other basics you'll need to know. Let's say these two items were always going to be moved together, or for organizational purposes these were your main items. You can select them both, press Ctrl G, and that will put them into a group, which again you can double click, main items, there we go. So now you have these in a group. Now this allows me to also go a bit further into pivot points, because we've got in the center of the object, you'll see where we manipulate this. This is the pivot point of the object, and it's the point at which the object will pivot. So turn it around this way, it's always going to pivot from that central location. The same with the sphere. It's going to pivot around the center of the sphere. Now this is not always optimal. You're going to need to change this pivot point sometimes for various different reasons, and I'm sure we'll have to do that at some point during the modeling portion of this. But for now, if you did want to move the pivot point, you just hit insert, and that will move the pivot point up, let's say. Insert again, and this time when I rotate, you'll see it's rotating around that pivot point. Now this becomes very important when you're modeling for manipulation, and again it's something we'll discuss later, but for right now you should simply know you can move that pivot point, and when you put items in a group they get their own pivot point. So this is another way to manipulate items. So if you wanted to stack these on top of each other and they were in a line, well, you can manipulate the group pivot point, and there you have it. So we're going to draw this part of the tutorial to a close, and in the next part we're going to look at topology, the actual organizations of these faces, lines and vertex, what makes good topology and what makes bad topology. Because on the surface of it, Maya seems quite easy to do something like a Lego brick. I mean, we can demonstrate the principle here by bringing in the cube and then bringing in, let's say, a cylinder, and we can just scale the cylinder down and plonk it on top of the cube, and there you would have a Lego brick. Let's delete this floor so we can see it better. This is not going to work for a variety of reasons, and we'll get into that on the next part. We'll also be, taking this quite slow for the next part when we discuss topology, and then we'll be speeding up. So, don't worry if you haven't memorized everything from this part. We'll be covering it again, and I'll always mention what keys I'll be pushing on the keyboard for you guys. So hopefully, if you are new to Maya, this has given you some small understanding. There's a lot more to it, of course, which we'll be covering in later lessons, but hopefully this has given you enough understanding to be able to follow along with the main body of the tutorial. So thank you very much for watching, and I hope to see you in the next part. Okay, welcome back. So we are in our viewport now with this fake Lego brick we made here, and because we have no ground, I'm going to just create a polygon plane, hit R to scale it up to give us a ground. We could have also got rid of that, and another way is just to use the virtual grid, which you will find here. So whichever you prefer. A lot of people I know like to work on a ground plane, a lot like to work on the grid. It's horses for courses, really. So we've got this Lego brick here, and as I said, on the surface of it seems quite simple. We are done, we can all go home and have tea. Unfortunately, it's really not that simple. So let's delete our old main items up here, and here I would name this brick top and brick bottom. As I say, we're not working with a specific naming convention in this case. We are just naming things so they make sense. Okay, so we've got the brick top and brick bottom. Now, the problem is Lego has a nice kind of chamfered edge, so it has a nice beveled edge. And generally we would achieve this by smoothing an object. And if I hit 3 to smooth it here, you'll see it disappears into a ball, and then I smooth this one, and yep, that no longer really looks like a Lego brick. So these are the kind of problems we need to solve, and this is the sort of thing that we'll need to do by modeling extra detail in these items. So not everything is quite as simple as it appears. So let's talk now about why this is bad and how we would get good topology, and what makes indeed good and bad topology. So in Maya you have a unsmooth view, which is this, and if you hit 3 on the keyboard you will go to a smooth view. Now the smooth view will smooth between the edges, so in here we have nothing to stop this just smoothing into a sphere. So first of all, if we wanted to make this a box with nice edges, we would need to put in extra geometry to control the degree of smoothing. So if we go to the modeling toolkit here, multi-cut will allow you to cut between points, between edges, and cut across faces. If you hold Control with a multi-cut active, you'll see a green line comes in. This is an edge loop. This will go around the whole model. So if we wanted to control the smoothing on this, and we know Maya is going to smooth between the closest two edges, we could put a control loop in here, which will then only smooth between these two edges, but it's going to smooth straight across the top, so you would need a control loop in here, a control loop in here, and again I'm just holding Control, and finally one in here. So these are the loops you would put in to control smoothing. And one here, and of course we need one extra here. Okay, so now when I smooth this, it will become, I'm going to go into object mode by right clicking and just going up here to select object mode. It would become much more cube-like when we are in the smooth view. I'm going to hit Q on the keyboard to cancel the multi-cut tool, and I'm going to click away so the wireframe goes away. Now you'll see here we have a perfectly smooth cube with those lovely beveled edges. This is because we use these extra edges to control the smoothing on the geometry. And this is done very, very often in Maya. It's one of those things that's a basic principle of modeling in Maya, using edges to control smoothing. So again, 1 unsmoothed, 3 smoothed, and this is what you'll get. Now this will also render when we get into that, smoothed. So Arnold will render a smooth copy of this, or if you're on 1, it will render a lower polygon version, because what the smoothing does is basically smooth between those control edges. So you see, very important technique to understand where to put your edges to control your smoothing. Now the geometry on this cube at the moment is perfect, and by that I mean it's all quads. So if we were to select a face by holding the right mouse button and going to face, and we select any of these faces, they all have 4 edges. Now they don't have to be perfect squares, so if we were to select a vertex, let's say, and move this vertex here, like so, okay, these are still all quads. We just mean by quads that it's a face with 4 edges, which means when I use my multi-cut tool, I can cut in edges all over this thing. It's not a problem, and that will cut them all the way around. Now when we start introducing bad topology to a model, so let's do that. Let's go here, so I just on the multi-cut tool, I clicked on this vertex, and you'll see it highlights the vertex. I'm going to click on it, you get a green line, I'm going to press enter, and that will divide this face up into 2 triangles. So now we have 3 edges per polygon. And now if I try and use the multi-cut tool, you see it won't work. It goes to here and then stops, because half of the tools in Maya will not work with non-quadded geometry, which gives us a real problem when we're modeling later on, because I want to put an edge loop all the way around this thing, and if I try with control now, I end up with this bizarre configuration of, it's a mess now. And we very quickly got into that mess by just having a triangle in the mesh. Now, triangles aren't the end of the world. You're going to occasionally live with them, and if they're on a flat surface that won't deform, generally they're okay. You should try and avoid them. Sometimes when a model gets very complicated, avoiding a triangle becomes very difficult. So if you have a small triangle somewhere on there, sometimes you just have to live with that. It's better to avoid them if you can, because as I say, now our edge loop tools are not working. So let's go to multi-cut, and you'll see here, control, no, I can't do it. And now, yeah, it won't cut across these faces. You can do it manually, of course. I could do this manually, but again, this is going to take more time. Now, by doing this manually as well, I've now introduced a much, much larger problem. Triangles you can live with. What's called an n-gon, which is a polygon with more than 4 sides, so a polygon with 6 sides, 10 sides, it doesn't matter. These are very bad news. Not only will they stop your edge loops going correctly, they'll also cause major problems when you try and deform the model, when you try and smooth it. They'll cause huge problems when you hand it off to, say, the effects department, or if you're doing your own effects and you want to use Bifrost to pour water on this, or you want to use bullet physics to explode it. This here, with this face, look at a face and select it, it has 1, 2, 3, 4, 5, 6 edges. So this is an n-gon. And n-gons are bad. You should make every effort to never have one in your topology. On a flat laminar surface that's never going to deform, you can get away with these, but it's very bad practice. So I see so many models that look quite nice, but they have lots of triangles, lots of n-gons, which makes them next to impossible to animate in any sort of soft way. So anything like if you were bending an arm and it had an n-gon on the bend, it just would not deform correctly, and it's never going to look correct. So just a few things to avoid. When we say good topology, we're talking about all quads. We're also talking generally about evenly spaced lines. So if you were putting lines all the way down this thing, And you would want them evenly spaced. You wouldn't want this sort of thing if you could avoid it. If these lines are not actually doing a lot, then you'd want to space them together. Another thing you're also going to want to avoid, although this is much less of a problem, is what's called a pole. So if we just cut across here with a multi-cut tool, and then we cut across here, and then we cut across here, and then cut across here. So I'm just cutting at random now, really. What you've got is a lot of lines that all converge to the same place. Now, if this was all quadded, it's not, it's triangles at the moment, which is a problem. But, if it was all quadded and it had this pole in the middle, so a point whereby lots of lines originate from, this can also be a large problem when it comes to deformations. So these are also to be avoided. They're not as bad as having triangles at a deformation point, generally speaking, or a lot of triangles, and they're certainly not as bad as n-gons. But depending on what you are trying to model and for what purpose, if in our case we're making a Lego brick, having a few poles in there is not going to matter, because Lego doesn't really bend. It would snap, I think, before it bent that much. But if you're modeling an organic character, these poles can be an issue. So when we look at the overall topology of an item, we are looking for quadded geometry that is nicely spaced. We're looking for little or no triangles, and we are most certainly looking for no n-gons. So here is 1, 2, 3, 4, 5. And that's to be avoided at all costs. And if I smooth this now, you'll see what happens with this n-gon. The geometry is just absolutely useless when it's smoothed, and we've got lucky here because we still seem to have a fairly good looking cube in the smooth view, but this is just nasty. And you can see the pole in there. You can see where we've had the triangles. We've gone from sort of very, very nice geometry look like this to very hideous geometry like this, and this can cause artifacting in the smooth view. It can cause your models to look wrong. It certainly makes going forward and adding bits to this model far more complicated than it needs to be. For instance, on this side, if I wanted to pull this space out to create sort of a shelf, let's say, I can select it, and again using our tools, this time the extrude tool, which will allow me to extrude things outwards, I can pull this outwards and I get a fairly smooth view shelf, and this has its divisions set to 20, so you can either alter it manually, or if you move your mouse over it, the actual lettering, hold the middle mouse button down, you can interactively drag it like so, and most of the tools of this will work the same way. So you can see here I have now this shelf that sticks out. Now if we smooth it, we're going to get that problem of no controlling edges, but this is very simple here. We just put a controlling edge in here, same as we did for the box. We're just looking to control how much this smooths. So again, if I wanted to not smooth it all the way back here, it would be like so, and these sides would need a controlling edge, so one here and one here. So 3, and we've got perfect, basically. Pull a little shelf out of this, the start of a grand piano maybe, use your imagination on this, but the point is it was extremely easy to do, very easy to pull out, very easy to put the control edges in, because we're working with all polygons. Now, all quadded polys. So let's try the same trick on this side. So let's select the face that now looks like this, extrude it, and come out like so, and let's do divisions, so middle mouse drag and put that down to 0. Oops, I actually hit a key by mistake, so put that down to 0. And now let's just have a look at this. It's a nightmare. You've got all the artifacting here and here. This just looks horrible. If we wanted to get this back to perfectly straight, we'd end up pushing and pulling vertices around for the rest of our lives, and as we do this, the topology of the model gets even worse. If we want to put a control edge in, so let's just go back to the non-smooth view. If we want to put a control edge in here, well, luckily enough our multi-cut worked that way, but it will not cut across this front face, you can see. So just now putting the control edges in becomes a nightmare. I'd have to put one in here, cut manually, then come down here, put one in here. So on the surface of it, when you first start with Maya, it can seem like all of the time and trouble that we go to create good topology is a bit of a waste of time. As we saw with our original Lego brick model, one cube, one cylinder, and it looks perfectly reasonable. However, as you start to delve a bit deeper, you'll find that there are a lot of pitfalls you can fall into, and a lot of people that start using Maya that don't concentrate on topology right from the start end up hitting a wall at some point where their work simply can't progress any further because they've frankly got the basics wrong. So in the next part of this tutorial, we're actually going to start modeling our Lego car. Now I just wanted to run over a few basics with you so you can get some of the thought processes behind why we model it in the way we do and why it can look perhaps overly complicated. So I hope this has been useful to you, and I hope this information will allow you to go out and look at if you've already started with Maya, maybe look at the topology of your own models if you haven't really concentrated on that, and hopefully show you some of the flaws in why, as you get further down the modeling process, it's become more and more complicated to build the shapes that you want because you've ended up, well, in a bit of a pickle like we are on this side of the cube. Alright, so I will see you in the next part when we will go over modeling proper. Now there's a lot more to learn about Maya than this. This is the very basics of topology and movement, but I think that we would be better off now learning as we go. So let's get on to do something interesting and make our first Lego brick. Thank you very much for watching, and I hope this has been useful for you. Welcome back. So in the previous few lessons we've just discussed moving around the interface, moving objects around, and indeed what makes good topology and what makes bad topology, and the reason why you'd want one over the other. Now right now we're actually going to get started by making our Lego blocks. So the first thing you need before you go any further is to make a Maya project. This is because Maya organizes its data, so texture images go in one folder, data from caching and animation goes in another, data from effects caching goes in another directory, data objects, OBJs you might import, all of this all has its own directory structure. So in order to get Maya to create this for us, we need to go to the project window, and I'm going to hit new project, and mine is in location Z. It's one of my network drives, but you can also open this up and give it a new location, and I'm going to give it a project name of Lego car tutorial, and this will then go and create all of these directories for us where Maya will automatically save its scenes, templates, images, render data, etc. So we're going to hit accept, and that will go in and create that project folder, and if I was to go to file open right now, you would see I have opened up in Lego car tutorial scenes, and these are all of our directories. So the important ones for us, or will be during the course of this tutorial, are obviously the scenes folder, because this will contain our saved scenes, and the source images, because this will contain our textures if we use any, which we will be, but probably not in this series of videos. And then you've got the images folder, which will store out saved rendered images, which we'll have some of, but also you can use this directory to put in your assets, so your image planes. Now, talking of image planes, the key to modeling a good object is reference. Always reference. I don't care if you're modeling a house, a car, a person, a Lego brick, you need reference. The more, the merrier. So I've gone out, and I only had my phone camera on me, so apologies for the crudity of these pictures, but they're good enough for our purposes. So you need to collect reference, and the more you have, the better. So I've got some general reference here, some close-up shots, and some one-on-one brick shots. Okay, so the side, the top, the bottom, the more reference you have, the better. If you're working, say, trying to model a car, your best bet is, if you don't have access to the actual car, is to go and buy a small toy model and then photograph it from lots of angles. The same thing, if you're going to make a Lego car, your best bet is to go out and buy it. I mean, it costs a couple of bucks, and the reference is going to be much better than if you'd have just searched around on the internet. It is always worth taking the extra time to collect good reference. But once we've got the raw photographs, we need to turn them into something Maya can use. So what we would want is to go into Maya and have in our camera angles different reference planes. So we'd want one from the top, one from the front, or maybe one from the bottom, one from the side, and this will allow us to much more easily match up our Lego brick with a real Lego brick. So now we need to make these image planes. It's fairly simple to do. I've opened up some reference here in Photoshop, specifically one of these big bricks top and bottom, and one of these small 2 bricks top, bottom and side. Now we'll be modeling not just the standard Lego brick, we'll be modeling some wheels, some oddly shaped bricks, but we're going to start off with this, and to get our reference for it we're going to just crop out the picture because we don't need the whole thing. So just get this and crop it, image, crop. So even with a little phone camera you can take, pictures that are good enough for this kind of thing. I'm going to double click this so it's off a background image, then I'm going to hit Control T, and I'm just going to straighten this as much as humanly possible. Now we're not going for millimeter precision, we're not going for thousandths of an inch precision, so this doesn't need to be perfect. This in this case is straight enough. You could use some of the transform tools in Photoshop to straighten it, but for something this simple it's not really necessary. Now I'm going to go over here, I'm going to take this image and I'm just going to drag it over to the first one, and all I'm going to do is line these up. So let's go to opacity 50% and just line them up. So this one is slightly smaller scale than this one, so let's scale it up a bit. And again, just with my little phone camera here, you're never going to get this perfect, but it doesn't need to be. This is close enough for this kind of work, most certainly. There we go. So now we've got the top and the bottom of this Lego brick. Okay, so I'm going to do the same with these 3 Lego bricks. So once again I'm going to cut out, and it doesn't matter what size these image planes are. Obviously if you have huge ones, sort of 8K, you might want to scale them down a bit if you don't need the extra detail. Just crop this out here, and again Control T to just try and get it straight, or as straight as it possibly can be. There we go, close enough. Now we're going to take this one, I think, and drag it onto the side. Doesn't matter which order you do this in, and we need to get those the same size. So again I'm going to just fiddle with the opacity here and maybe straighten this one up, double click it so it's not a background layer anymore, and just straighten that one up as much as possible. Again, nothing at all complicated here, and get them so they're the same size. And as luck would have it, they appear to be the same size. So that's great. Let's just put this one up to the top here. This one doesn't really matter. You can have it in the middle. You'll be able to move it around in Maya as well, so there is a certain flexibility there. And that's 2 of these reference images. Let's get the third one. Here we go. Just drag it over, pop it on. Let us just make it opaque. We'll do the crop in the end. And we're going to match this one to the bottom one. So again, as luck would have it, we are almost there. Okay, I think that's about lined up. Let me just flip backwards and forwards. Okay, yeah, that seems to be pretty much perfectly on top of the other one. Alright, so now we can do a final crop. Let's just make sure we are on the biggest image. Let's turn those off, and we'll crop it here. So just image, crop. So you should now have, let's put the opacity back to 100%, and this one that comes in right on the top of that one. Yes, I should think close enough for this. Let me just check that again because it seemed to be a little out. It's maybe a tiny bit out, but it will be close enough. Alright, so this is the reference for our Lego bricks. Now, I've shot a lot more reference than this, so during the course of the tutorial I will be cutting out reference, but I really think this is quite self-explanatory. All you're doing here is lining up your reference in Photoshop so it sits nicely one atop the other. So I'm going to go ahead and save these out to the images directory of our project folder, which will be, let's see, in our case, Z Lego car tutorial images. So I'll be back in a moment after I've saved out this reference. Okay, so I've gone ahead and saved out all that reference into the images directory of our project folder, and now it's time to bring it into Maya. So if we click here to go to the foreview, now we can start to bring our image planes in. So let's go and view, image plane, import image. We know we're in the images directory, so I'm going to do this small Lego brick first. So 2 times 1 bottom, we're in the top view, Y. So we're going to just open this up like so. Now at the moment it's visible in all views, and you can actually set it to a specific camera, which we might do in a little while. But for right now, I'm going to just take view, image plane, import image, and I'm going to import the side view. So let's go to images here and side, open, and you can see that side view is no good, it's coming the wrong way up, but this is not an issue. We're just going to press E to rotate, J to lock that rotation, and then spin it round until it's 90 again. In fact, what I've done there is I've grabbed 2 axes at the same time. So let's re-import that. Import image and images and side. So you have to be careful when grabbing axes. You can grab them slightly off kilter. So I grabbed the yellow one that allows you to pull it around in all sorts of directions, like so, in more than one axis, when what I actually wanted was blue. Hold J to lock rotations and just scale it around like so. Now because we lined it up in Photoshop, it just should be a case of putting this on the ground plane here, or our virtual ground plane, so lift it up. There we go. And if we look in this view, what we've got is perfect reference for Lego. Now we've got no bottom at the moment, because the bottom's going to come into play in a little while, and I'll probably just swap out this image plane from top to bottom as and when I need it. If you needed a specific orthographic bottom view, you can go Panels, Orthographic, New, Bottom, and that will create a bottom camera for you, but in our case we don't need one just yet. So let's get a start on our Lego brick. So we're going to start out with a cube, as you might expect, and again the 4 views can come in very handy for placing stuff like this. So let's go to the side, let's put this one here, and what I'm going to attempt here is to just model one brick, so a 1 by 1 brick first of all. So I'm going to grab both the image planes and I'm actually going to move them until this is on the center line. So we are now halfway through one Lego brick instead of both of them, because in this case we're just going to model one. So let's make sure that's as centered as we can possibly make it. So that seems to be about right, and we will be modeling from here. So take our box, vertex, shift and drag around, drag a selection out to here. So we're covering the image plane there. Shift and drag it out to here, which would be the center line. Now, as I said before, we don't need to be millimeter perfect here. We're within probably 1 millimeter, so that will work fine. Go up this way, and that builds us the right size cube to make Lego out of, but only in one direction. If we look at the top view, you'll see we are far too thin. So click and drag around again, pull it out to here, pull it out to here, and that seems to be about perfect. So that would be the size of a 1 Lego. Now the reason we're going to build a 1 Lego first is because we can then use it and duplicate it across to build the more complex Legos. Although we will be taking the long way around on some of this modeling, just so I can demonstrate some extra techniques. So some things that could be duplicated we'll actually model again for the practice, and for me to be able to explain the workflow a little better. Okay, so that gives us our basic brick shape. Now we need this top part. So let's go with a cylinder again and move this cylinder up until it's in position. So let's get the bottom of it flush with the bottom of our cube, and you don't have to be perfect, but get it as close as you can. Vertex, before I edit the vertex, actually, if we look at this, if we were to take an example from our topology, and this needs to be connected to this, Well, we couldn't have this just sitting on this, even if they were connected together, because then this surface here would become an n-gon, because it would have more than 4 sides. And if we branch out geometry from this, it's going to get very complicated, because this thing has lots and lots of edges. So we can go into our channel box, under inputs, polycylinder, let's give it 8, which is a much more reasonable number to work with, and when we press 3 to smooth, you can see it goes pretty round. So we don't need more geometry than this, and the less geometry we have, the easier it will be to split this up. Okay, so come in and just scale this down. So vertex. The reason we did that before we did the vertex, by the way, is because once you start changing vertex, this input no longer works. Well, it will work, but it will have very unexpected results a lot of the time. So get the right geometry for your object before you start to move its vertices, or its faces, or its edges even. Let's just select all those vertices up there and move this down until it's at the top of the Lego brick, like so. So now we've got the perfect size. Because of the way we organize this, this is coming straight up from the grid, so we know it's in the middle, or we're fairly confident it's in the middle. And now we've got the job of connecting these two things together. Now I could, and I'm going to have to combine these, and the reason for that is these are two separate objects at the moment. Even after I combine them, there'll be two separate objects, but Maya will treat them like one. And the reason for this is, if I wanted to say, draw an edge from here to here, bridge an edge from here to here, I need to select this edge, like so, but then I would need to select this edge. And as soon as I click on this one, it clicks off that one. So in order to work on two objects as if they were one, we have to combine the mesh. Now, before I do that, there's a few things I want to get rid of. So for instance, this top face, I don't want it. This bottom face, and let's do something else before we continue, because you can see my image planes are starting to get in the way. So I'm going to select both the image planes. Here in the channel box under display, these are display layers, click create a new layer with selected objects. So that's that one. So that will create a layer and put these two objects that I have selected into it. Okay, so if you want to select multiple objects, it's just shift. So select that one, click here, that will put them in their own layer. So of course, being neat and tidy, we want to call this, let's see, image planes, and save it. And that will now be saved. The nice thing is we can now flick the visibility on and off. We can set this layer to a reference standard, so if you put that as R there, it means I'll no longer be able to select them if they're on reference. So this is a good way of having image planes in the scene, but you're not constantly accidentally clicking on them. So let's turn that off reference, and let's turn that off visibility, and now my image planes are invisible, which means I can take this bottom face, because our Lego is hollow of course, and delete it. Now the reason we deleted the top face is we're actually going to bridge across this gap and create a new face. Now we could have done it by cutting a hole out of the old one, but that would have just taken more time. So we need this to be one object, as we discussed, because without that we're not going to be able to select the edges of the two separate things. So select and select, mesh, combine. And Maya hasn't. For some reason, Maya 2017, this is an extremely simple operation, and Maya 2017 sometimes decides that it's not going to do the combine. I don't know why. It takes its ball, goes home, and stops playing. But for whatever that reason is, you might have to hit combine twice. Maybe it's a bug in this service pack in Maya, I should hope so. So, modeling toolkit. Because as we look now, and we start to pay attention to topology, this has 8 sides, of course. 1, 2, 3, 4, 5, 6, 7, 8. And we need to attach it to this, but this only has 4 sides. So that's going to leave us with a huge pickle. So the easy way is to either take 4 edges out of this, so it's 4-sided, but then it wouldn't be round, or put extra faces in this. And the way we put extra faces in is by using our multi-tool with control, multi-cut tool with control, holding shift so it snaps into place, and getting it into the middle and putting an edge. So now we have 1, 2, 3, 4, 5 faces on the cube, Now we have 6. Now we have 7. Now we have 8. So we have an equal number of edges here as here. So now it's just a case of bridging these edges together. And because Maya has combined these to be one object, I can now click here, shift click here, and hit bridge. Okay, so if you noticed, let me just pull that up again, we have no bridge and we have a very large error saying it's an invalid selection. Now we can see there's one edge and one edge, so that is in fact an equal number of edges we have selected, so there must be something else wrong. And if we take a look from the bottom, all of the bottom faces on this are still connected, so that will stop a bridging operation working. If we just delete these bottom faces by shift selecting them and hitting delete, when we go back and try this again, you'll now find that it works. Bridge. So you see this is bridged across here, creating a new face for us, and then we would just bridge all the way around, like so. Do this all 8 edges. There is a faster way, of course. You can just double click this edge, which you'll see here has highlighted the entire edge all the way around. Shift, double click this edge, and then hit bridge. And that will do them all at the same time. Okay, so now we have an object that's all one. We're not looking much like Lego yet, but that's because we haven't put the control edges in here. So we're going to run into one problem. If I use the multi-cut tool with control here to put a control edge here and a control edge here, you'll see these edge loops run all the way across to the top where we have triangles, which you often have on a cylinder like this, and because this will remain flat, that's not such a huge issue for us. Now, big problem, yes, because we've got this edge running all the way up here, so when we smooth it, this will get a nasty crease along this, which we don't want. So we'll sort that out in a second. Let's put some other control edges in first. So let's do this one. Let's put one here, one here, one here. Now, because this is tries at the top, we're going to have to cut this in manually. So just come down until you find about 5% should do. Hold, click, so you can drag a point like so. Click and hold, and then press shift and you'll engage the snapping. And we know we were going for about 5%. So again, click and drag, press shift to engage snap, about 5%. Oops, for some reason that didn't seem to want to snap, so let's shift and drag again. There we go. Snap. Can be a tad temperamental, works 99% of the time. There we go. And shift and drag, and then just click on the final point to close it. Click enter, and that's cut an edge loop in manually. Okay, so we are putting the control loops in now to control smoothing, and if we look from the top view, this one is not very neat. It's not very even at all, and with topology, and these are kind of bent out of shape, so we must have done those original edges not quite in the center, but this can be fixed. Go to vertex mode, select these two here, and just move them back until they're straight. And the same with this, move it here until it's straight. Okay, in fact, if you want to make sure they're all straight along one line, we can select them all, hit R to scale, and scale them towards each other. This will straighten them all up. Okay, so now they're all on a perfectly straight line. Now, this outside edge is not straight, so again, we can pull this back in. Now, we could select these again and scale, because these ones are not quite straight, and there certainly is points for neatness when you're modeling. It matters where your geometry is placed, what it looks like. What will happen if you use this wavy line as a control line for smoothing, the smooth will look wavy, which for Lego is just not the look we're going for. So, you know, these things can seem quite trivial. Does it really matter if it has a tiny bend in it? Yes, in some cases it can really make quite a difference. So, and now this. Let's just pull this out. So it's a uniform width all the way around. Again, we're not aiming to be millimeter perfect, just so it doesn't look like a dog's breakfast. There we go, there we go, done. Okay, so that's the top smoothed now. So if we hit 3, you can see that that top Lego cylinder is looking really nice and smooth. Now we need to sort out the smoothing here. We need to come up with a way of putting edges in here and terminating them here without leaving an n-gon, a triangle, or any other such nastiness, and we can't have them follow up and go all the way across this, because that will create smoothing artifacts and the top of our Lego cylinder will no longer appear round. So as I said before, Lego seems very simple, you know, until you start to get into topology issues, and then it gets more and more complicated. But I think that's enough for one part, so I shall be back in the next part when we'll look at making the rest of this Lego block as well as making the inside of it. So I hope this has been of interest to you, and I shall be back in a while. Thanks for watching. Okay, let's continue here with our Lego brick. Now, before we go any further, it's important as keeping our scene organized, and what you'll see here is we have now one cube, because this is now one object. Now it's been merged in this way. If I take a vertex and pull it up, you can see that it's completely merged together. It's not simply combined anymore, it's actually merged. So, this was made from a cylinder and a cube. And this is the transform nodes from that cylinder and that cube, which obviously we don't need anymore. In fact, we don't need any of the history of this object slowing us down, cluttering up our workflow or anything else. So we select our object and go Edit, Delete by Type, History. That gets rid of those empty transform nodes and just leaves us with this nice piece of clean geometry, nice and organized there in our outliner. So we'll call this Lego, let's give it a 1. It is a 1 by 1, isn't it? Yeah, 1 by 1 Lego brick. Okay, so it keeps everything neat and organized. And this seems rather redundant right now, but we've only got one object here right now. You know, we have hundreds or thousands potentially of objects here, different things. So keeping organized is critical. Okay, let's get back and look at what we're going to do to put control edges in here. Now we could cut these in manually and then terminate them. I'm going to use the bevel tool simply because we haven't used it yet and I want to look at as many tools as possible. So select all 4 edges. This will also be slightly faster than cutting it in by hand because we can do all 4 at once. I'm going to press Q to get rid of the move tool pivot there. And I'm going to go to bevel. Now you'll see that's beveled in, but if we look at it from the top, it's also cropped us. This is a chamfer. This is a chamfered edge now, and we don't want that. So let's come in and turn chamfer off. Now I'm just middle mouse dragging that value, and you'll see we've got the edge we want. We've got segment 1. We can have more or less, but obviously less is good. The less we have, the less we have to deal with. And we did just want these control edges for smoothing. Now we can make them wider, or you know, we can make them smaller. About 0.5 in this case, luckily enough, would be about perfect, I think. So that's done all 4 edges, and we've got some triangles. Now in this position, triangles might cause us an issue because they're going to deform, they're going to smooth. But for right now, we'll leave that. We'll sort that out in a second, and we'll just put the last of the control edges in before we sort this out. So multi-cut, put a control edge in, and try and make it equidistant. So you know, you don't want it down here or right up here. You want it about the same distance as this one. Okay, so now we're almost there. We've got a few triangles left in our model that we really need to sort out. So easy way to do this is to delete this edge here. Now when deleting an edge, if you highlight it and hit delete in the keyboard, it will often leave its vertex behind. We don't want that at all. So in fact, let's get rid of all 3 of these edges, delete those edges, and then to make this a square, we simply need to cut from here to here, and then from here to here, and you'll notice that we have a quad, 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 and up here 1, 2, 3, 4, we have a quad. We have quads all the way around now. That's got rid of the triangles in the corner there, and we're all good. Let's come here. Again, I'm going to hit Q to get off the multi-cut tool. I'm going to select all these edges. I'm going to shift, right click, delete edge, and use the multi-cut tool to cut from here to here and then to here, and hit return. Just simply repeat this process with all 4 edges. So delete, and remember, not just delete on the keyboard, you will get in all sorts of problems doing that. And go. And same final one, I think. So delete the edge, come up here, multi-cut, click, click, and click. And we should be a fully quadded model apart from the top. So let's see if there's any way of fixing this. Now this one should be fairly simple, because if we look, we have 1 edge, 2 edge, 3 edge, 4 edge, but then this edge in the middle. So let's take it out. Delete edge. 1, 2, 3, 4. That's quadded. This is quadded. So once again, we are all quads. So then let's take out every second edge. So let's take this one, and this one, and this one. And now we have a fully quadded model. Now we're going to need a smoothing edge down the bottom here. And again, try and make it equidistant with these, the same distance. And hit 3, object mode, and there we go. We've got no smoothing artifacts. We have great corners, great roundness here, great beveling of the edges, and that is a great looking 1x1 Lego brick with good topology, and that is what makes all the difference. That's going to help us out down the line. We can now do dynamics with this. We could drop it in a puddle of water. We could hand it off to the texturing guys who wouldn't have a conniption at the geometry. So again, during the first parts we banged this in about good topology. Well, you know, it does make life a little more complicated, to be honest, but it simplifies the process further on down the pipeline. So for modeling simple things, it can, you know, seem a bit baffling to do all the extra work to get the good topology, but as soon as your object gets more and more complicated, you're going to wish you started with good topology in the first place. So now we've got an outside of this thing. It looks pretty decent, definitely very Lego-like. What we're going to need is an inside to it. Now this can be fairly simple to achieve by simply duplicating this object and making it the inside. Now there are a couple of issues we're going to run into with this, but first, before I duplicate it to make it the inside, I'm going to hit Control D. I am going to look under the channel box to make sure we're at a 0 transform, so we're not rotated or translated anywhere. I'm going to move it out of the way, and I'm going to call this one Lego Brick Master, and then I'm going to hide that. The reason I'm creating a master one is when we go to create a 2 long block or a 3 long block or a 5 long block, we can use this one and just duplicate it across and join it together. So we want to do that before we go ahead and put an inside in it and make it any more complicated. So drag it over there or anywhere you like, it doesn't matter. You can get it back to the origin of the grid by just resetting all this to 0. So it really doesn't matter where you put it. Just put it out the way and press Control H and hide it. Actually, I pressed Control G because I fat fingered the keyboard. Sorry about that. Control H, which will hide the object. If you want to show it again, you click it here in the outliner and press Shift H, and that will show it. So Control H. We've got a master Lego brick now that we will always have. So we've got our image planes. Now, before we can make an inside of this thing, we really need to know how thick the inside would be. I mean, how thick is a Lego brick? Do we want to wing it, or do we want to be a bit more accurate? Well, it's me, so I want to be a bit more accurate and reference for absolutely everything. So let's go in here and turn our image planes back on. Now, I can see this one. I'm going to select it. I'm just going to change the image. So instead of 2x1 Lego brick, I'm going to change it to images 1x1 Lego brick. Now this was the only 1x1 Lego brick I had. It was white, so I've just gone into Photoshop and drawn where the edges are so it's more easy to see. And I'm going to pull that in, and then I'm going to go to this view, and we can't see through this object. So let's go ahead and turn on shading X-ray, and now we can. I'm going to move this image plane here until it is in the right position. I'm going to scale it a little bit, so there, that should be enough in that direction, and then we'll move it into the center of the object. And if you're having trouble seeing, you can always turn on the wireframe on shaded, and that will bring the wireframe in. So this is the edge of our brick, so we know we need to scale this up so it's here like so, little smaller. Move it into position. It can be a bit finicky. Okay, so now we can see here how fat our Lego brick is. Okay, so let's make an inside. Now again, I've got these on a display layer, so channel box, turn off the visibility for now, and we can come in, select this, hit Control D to duplicate, so R to scale, and just scale it downwards. Now we're going to scale it downwards. Let's turn the image plane back on until this outer edge of the inside is to this outer edge here, and that will be how thick we are. So there we go. That's near perfect. We can turn the image planes back off. Okay, and I'm also going to move this down inside the Lego block, I think. No, I think that should actually be fine. So we do need to move this edge down to be in level with this edge. So come up, select the edge, I've selected the wrong object there. Double tap the edge, so double click it, and then just move it down until it's at level with the bottom. So again, if you're having trouble seeing that, you can turn on shading X-ray, and you'll be able to see and move it down. Now we've also got its smoothing edge, so I'm also going to move that down. There we go. And that should be about in line. But of course, about in line is never going to be good enough for us. So when we join these two objects together, which we'll do in a moment, we'll select the vertices along the bottom, scale them inwards so they're all perfectly planar to each other. Now the reason we can't join this straight together is if you can see in Maya, you see all these faces are black. So these faces are black, these faces are grey. Black faces means that this should be inside a mesh. So at the moment, because the way we cut and scaled this down, it thinks these faces are the inside, whereas this will be the outer portion of our Lego brick. This will be sort of inside the model, this will be outside. Now, if you go up to lighting and turn on two-sided lighting, that will get rid of that effect, so it will just look like all of the faces are the same. So you should always be modeling with two-sided lighting off, because then you can see, which faces should be on the inside of a model and which faces should be on the outside. So at the moment it thinks these faces should be on the outside of the model. They're not going to be. As soon as we bridge across here, they'll be inside the model. So a very quick way to fix this: select the whole thing, hit the space bar, which brings up in Maya the hot box, which is basically these menus up here. So when we switch this to the modeling menu, you'll see I've got a mesh, edit mesh, mesh tools. When I flick it to something like animation, that changes to playback, visualize, deform. So you can do this. You can go up to modeling, and I'm going to use the mesh display menu. So you could go here. Personally, I like to use what's called the hot box. You hit spacebar, and the whole box comes up. So it's all of the menus up here from all of the subsections in one place. This makes it much faster. So select the object we want to manipulate, hit space, go up to mesh display and reverse. That will change the surface order. So now this inner faces here are going to be on the inside of the model, which is good because that's where we want them. So black inside of the geometry, grey outside of the geometry. So edge mode, double tap this one, and we can't bridge just yet because we are two separate objects. So select both the objects, mesh combine, and again that didn't work. No, Maya really in this service pack version has a problem with that. For some reason it's a very simple command, but you might have to hit it twice. There we go. Hit this and this. Modeling toolkit, bridge. Now you see our bridge has come in, and this is not right at all, that we've got edges all over the place. Let's go to direction. No, this one. No, so let's change the offset until we get that the way we want it, which is like that. Perfect. So all these lines are coming out here. This one is coming up here. Now we know we've got a good thickness for our Lego brick because we saw it on the image plane here. Let's bring that image plane back. So channel box, visible image plane. We know we're at the correct thickness. Invisible image planes. And there is nothing else in a 1x1 Lego brick. It doesn't have anything that comes down the center. It's just like this. So let's go back to object mode, right click and object mode, hit 3 for smoothing, and we should have a perfect 1 Lego brick. Now, it's way too smoothed down here, which as we see, as we just bridge these edges, they've got nothing to control, and I'll just turn the grid off, they've got nothing to control the smoothing. So again, multi-cut, we'll put one thing to control the smoothing here, and one thing to control the smoothing here, just so it smooths from this edge to this one, so we get a nice smooth there, not all the way around. And let's check inside, do we have a controlling edge? Yes, we do. So again, Q to cancel the multi-cut tool, object mode 3, and we've got a perfect little Lego brick with very nice topology. Okay, so Lego brick 2, just delete the history of it, edit, delete by type, history. That gets rid of all those empty transform nodes. You'll see here I've got a completely empty node. I can just delete it. Okay, so Lego brick, one by one Lego brick. And that doesn't have to be called Lego brick 2, it can just be called Lego brick. Done. Just bring a plane in so we can see that on the floor. Got the right thickness, got an inside, got an outside, the faces on the inside and outside are all pointing the right way. The topology is all good, the smoothing is good, and that's the way you make a 1x1 Lego brick. Well, there are several ways to do it. This is one of them, and this is a fairly successful one. So I'll be back in the next part when we'll look at making a sort of maybe a 4x4 or a 2x6 or a different shaped block, because those blocks are much more complicated because they have geometry coming down from the centerpiece to connect them with the bricks that stick up. So they're a little bit more complicated. So we'll tackle those next, and then we'll be on to some specialist Lego blocks that will present their own challenges. So I very much hope you found this useful, and I will see you in the next part. Thanks for watching. Hi, welcome back. So we left off with our little 1x1 Lego brick here, capable of being perfectly smoothed, and in this part we're going to look at how we can reuse some of this to make a 1x2 block. Now the 1x2 blocks are a bit more complicated because they have a pole that comes down from the center of them, which we'll see on the reference in a second. But for right now we're interested in reusing parts we've already made for the simple reason that it's faster. You know, you've already made the basic shape of a brick here, so we'll reuse this to make a 2 brick. So in this regard, let's hit Ctrl and D to duplicate this, and we'll call this Lego brick done. So we'll have one copy that we can say is done, and in order to get this out of the way I could use Ctrl H to hide it, but a better idea, as we'll end up with quite a few Lego bricks, is to go over to the channel box here, create a new layer and add selected objects, like so, and that way if we turn off the visibility you'll see that my brick there disappears. Okay, give this one a name, let's call it finished underscore bricks, and all of our finished bricks can be stored in this layer. Now if you want to store something in a layer and you didn't when you were creating it, you can simply click on the object you want to store on that layer, click here and click add selected objects. Now why didn't that name change? Because I forgot to press save. There we go. So we have a finished bricks display layer, which we can turn off. So all of our finished bricks can live in there. It just helps keep us nice and organized and tidy. Now press 1 if you're on the smooth view to get this to the non-smooth view, because typically you'll pretty much be modeling a hard surface object like this in the non-smooth view. And then let's go to one of the side views here, In fact, the top view might be a good one to do this in. So we're going to eventually mirror this in X. So this way, as you can see by the little pointer here, and this way is X. So to reuse this thing, we really need to cut the faces off it. So let's come in and select face, come up here, cut these faces off. Now we can check in the perspective view that those are the faces that we want, because when we mirror, we don't want a situation where we end up with a bunch of faces connected to each other inside the model. Now we could just take these front faces like so, which would be easier. So you can do it with the drag select or just hold shift, but that will leave us with some extra geometry that we perhaps don't need. So it probably is better to come in and take all this away as well, because this is all part of holding the edges, and obviously when we mirror this, this will be in the center of the model and will not need it. So you're always going to try and look for ways to simplify your geometry. The lower the polygon count, the easier it will be in the end to continue working on it. Okay, so that looks like all of those controlling edges, both top and bottom. Now, because we're selecting faces and not edges, we can just hit delete on the keyboard and that whole thing goes away. Now, of course, we need to do the same for the inside here. So just select these edges, and all you're getting is these controlling edges and the front faces. As I say, we don't need controlling edges in the middle of a model, so there is little point to keeping them. Now again, you'll notice, I'll point it out again, that the inside of the model is black and the outside of the model is grey. If you're not actually seeing this, it's because you've got two-sided lighting turned on. So make sure that's turned off always when you're modeling. Otherwise you'll get in a situation where you have this showing. So let's just turn on two-sided lighting, and you can't tell which of the front faces and which of the back faces, which can become a real problem later on. As I think I already showed you, you wouldn't be able to bridge across if one face was in the wrong direction, so it becomes a bit of an issue when you're using the tools and whatnot. Now we need to straighten these things up together, so let's select an edge down here, this one, and then shift select the corresponding edge and double click. Okay, that's selecting the outside edges, as you can see. So that selection would be no good for us. So let's try from here, shift select here, and that's selected the inside edge that we want, but not quite all of it. So let's go up and finish selecting this edge. Okay, and now we're just going to move this out with the W key so it kind of just bisects this a little bit. Now, with those edges selected, we're going to hit Control, press the right mouse button and go to vertex, which will convert that edge selection to a vertex selection. It's often much easier to select a row of edges than it is to individually select vertex like this. So this is looking fine. Now we can press R on the keyboard and scale these vertex back straight. Okay, when you can't scale anymore, you know they're straight. Sometimes it doesn't go to a complete lock on the handle. What will happen is it will bounce back and up and down. It'll just go completely ballistic. That also means that you're straight. So from here we can go into an appropriate view, in this case the front view, hit W again and move this back so it's all perfectly in line. Then we can do a larger vertex selection, R to scale again, and get it perfectly in line. Now you'll see my handle has gone to that sort of wig out thing where it does, you know, bounces backwards and forwards. This means we're perfectly in a line. Okay, so now we have a shape that doesn't have a controlling edge down the center and doesn't have any faces where we might mirror it, because if we were to, say, copy this geometry and spin it round and join it together, then if we'd have left those faces in place in the center of our model here, we would have had a bunch of extraneous faces and a bunch of geometry we didn't need. So let's now mirror this object, and if we look down here we can see we are in X, So we want to mirror it in X, we know this, and I'm going to use the hotbox again, so spacebar. You can use the menus up here, but you'll find that getting used to the hotbox does make the process a bit faster. So mesh, mirror, pop open its options here. Now we want to merge border vertices. Now this is an open border, so this would be a border edge, and the vertices along it would be border vertices. We know we want to mirror in X, and we want to mirror in positive X. So let's just hit apply, and you'll see what's happened. We've mirrored around the pivot point. Now I wanted to show you this as how important these pivot points can be. So let's take a look at why that went wrong. If I hit W, you'll see the pivot point for this object is in the center. So let me demonstrate by duplicating the object and then rotating it. Now it's going to mirror around that pivot point. So if we mirror in positive X, it will just do exactly what it did, this, because it's mirrored around the pivot point. Now let's get rid of that brick because we don't need it, and let's hit insert to move that pivot point, say out to here, then insert again to stop moving the pivot, Control D to duplicate the object, and now let's mirror it around X, or our fake mirror, just so we can see what's going on. And now you see it's mirrored. So the placement of this pivot is absolutely crucial when you're doing mirroring operations, as well as many other operations, but for us right now we're going to look at this from a mirroring perspective. So in order for this to mirror perfectly, this pivot needs to be perfectly centered and aligned to the front of this object. Now there's an easy way to do this. Hit insert to move the pivot, hit snap to points, just zoom in a little bit so you can see what's going on, and select the vertex right in the middle there, and your pivot will snap right up there nice and easily. Now when we hit mirror, you'll see that that mirrors across nice and simple, no mucking about. Now we've got a very large merge threshold here. That's far too large for what we need. That will be the distance at which vertices merge together. So let's come in and make this 0.05. That's a perfectly adequate merge distance for this, and then press Q to drop the tool off, and you'll see that you've got here a fairly perfectly formed double Lego brick. Now let's just make sure that merging these together didn't give us any n-gons. There's no reason why it should in this case, but we've got 1, 2, 3, 4, 1, 2, 3, 4. No, it all looks perfectly fine. It looks straight, nice, neat and orderly. We can check out if we are straight in the side view here by, say, selecting a line of vertex. Now you only want them all in one line, and I can see they're ever so slightly skewed, so I can just come in and scale them together until they won't scale anymore. That was a very minor thing and wouldn't have been necessary in this case, but it's always good to check to make sure that you're all in alignment before you start the next part of the modeling process, which in our case will be to put a little tube in the center of this. However, before I do that, I'm going to get a duplicate of this, because when we duplicate it over to become 4, that tube will have to change. So let's hit Control D, and we'll call this Lego brick. Let's call it 2 times Lego brick, and we'll just call that master, and Control H to hide it. Or you could create a master brick display layer, whichever suits. So let's just check the smoothing is all nice. Yeah, that's kind of perfect. And now we need to come in and look at creating the pole in the bottom. And to do that, I'm going to bring in the bottom image plane. So let's turn the image planes back on. And we've got the bottom image plane right now from a 1x1 brick. So let's go to the attribute editor and bring one in for the 2x2. So 2x2 bottom. No, that's not the 2x1. Sorry, bottom. There we go. And we can see the bottom of this. Now, in this orientation, we're going to want to rotate it. So E, press and hold J to snap your rotations, and just align this image plane with our brick. Now we're on snap to points. I'm going to come in here. I'm going to use the universal scale. Okay, and this will also allow us to check our brick for length and width. And it looks like we are, a little bit out here. Or are we? No, not really. This needs straightening up a bit. And we are a whisker too thick, but I'm not actually going to be that concerned about that at the moment. What we need to concern ourselves with is this pole in the center. So basically we would be probably about 1 millimeter out at this point on the width, and if I look at it from the top, you can see it's a very small amount. As long as our Lego bricks are the same size, that's fine. And you could of course just select these vertex down here and move them inwards a very small amount, but for me not necessary at the moment. So this view at present is on the top view, and we want to get it on a bottom view. So panels, orthographic, new, bottom, because we want to be looking at the bottom of our object. Now you see we've got a slight problem because we cannot see our object. So if we take our image plane and move it, that will allow us to see the bottom of our object here. So I'm going to turn this view off X-ray so you can see it a bit better, or put the wireframe on. Okay, and we can now see that this is the center of our brick, and this is the pole that we have to recreate. So in order for us to have some guide on what we're doing, I'm going to bring in a polycylinder. I'm going to get it perfectly aligned to the axis. I'm going to scale it down. We're going to use this as a cutting guide. Okay, like so. And I'm going to give it 8 divisions, the same as we have on the top here. So go to the channel box, inputs polycylinder, 8 divisions. Okay, make sure that's lined up with the reference, but also lined up with our own model. And so we're going to line the center line of this up with this, and the center line of this up with this, which it is. And then we're going to use the multi-cut tool to cut out the appropriate space on our model. So this one here is really just for reference. Now select your model here, select the multi-cut tool, multi-cut, and we're going to click and drag until we get to the correct point, click and drag until we get to the correct point, click and drag all the way around, just using this as a reference. Because, you know, if we tried to do this freehand with no reference in there, or we tried to cut round the circle itself, that could be a bit tricky because we're looking to cut an octagon, not a perfect circle. So it's better, if you can, to bring reference in. Always reference. And let's cut that out. Now I can get rid of this. I'm just going to flick to the big view and flick to object mode. There we go. Now I can get rid of this. And you'll see on the bottom of our model here has been cut this octagon. Now right now this is a perfect quad, but we're going to need to put some control edges in it. So let's see here. Yeah, that should be fine. Let's go face, 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 and that's made this an n-gon. So you can see here we've got 1, 2, 3, 4, 5, 6. You should be constantly looking at this. So in this case it would be better to have a triangle in the middle, then an n-gon on all the sides. Now we can come back in a bit later and look to see if it's worth changing the topology here. So we've still got n-gons here, so we need to connect this up like so, which sorts this out. So 1, 2, 3, 4, 1, 2, 3, 4, but then this is an n-gon. So we'll cut from here to here, and we're going to have to cut a loop all of the way around this thing, because look, we now have n-gons going down, or we would do. So let's use the multi-cut tool, and I'm going to go back to object mode, multi-cut, and I'm just going to put an edge loop in like so. Let's see what that does to the outside of our model though, because I've got a feeling that that's going to be nasty. Yes, we cannot have this. So let's turn the image planes off. And this is where you really need to sit down. Let's take that edge loop out and think about your geometry. Let's turn the image planes off. So let's see what we could do here to make this a little neater. So let's take this one out. Shift delete edge. Whoops, I'm on the multi-cut tool, so let's come off that, go into edge mode, and shift delete edge. Remember not to use delete on the keyboard. And right, so this is not going to work. This does sort this out, and it sorts this out, but it's going to leave us with the problem of having to connect all these edges up hither and yon. So a better place to split this, looking at it quickly, would be to split it from here to here. Okay, that still gives us 1, 2, 3, 4 edges. 1, 2, 3, 4, 1, 2, 3, 4. Okay, so this is a better split point. Now, that leaves us with a pole here. But as I said, on a non-deformable surface, especially at this region, that pole is not going to be an issue. It's certainly going to be a lot less of an issue than having a chuffing grey n-gong, or hundreds of triangles, or a model that's split into now 300 additional pieces. So you've got to look around and find the best way to do this sort of thing. And it's not often obvious. It often is a very time-consuming process to figure out how to cut these things in the best manner. So let's just check our faces here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. So it seems like we're fine. Now we can do the trick of selecting the edges here. At least we should be able to. Let's see. Delete edge. So let's see if that's changed the equation. This is now a quad. So we have 1, 2, 3, 4 sides, and it hasn't altered the topology of any of those. So now we've got a nice quad in the center of our model. I mean, triangles in this case would have been fine also. But extrude it downwards. Click so we center the extrusion. Go into a view where you can see what's going on. And I've actually got one of these Lego bricks in front of me, and the pole extrusion comes down to, it looks like on mine, exactly the bottom of the brick. But these things are made to a certain tolerance, so millimeter or fractions of a millimeter off won't be an issue. Now I'm just going to level the divisions down to 1 because we don't want extra geometry that we don't need. I'm going to go to object mode, and then we'll need to put some smoothing edges in here. So let's go up to the top and multi-cut. So we want one edge to hold it together here. We'll want one edge to hold it together here. And you'll notice now we have all quads and everything. We can just use the multi-cut tool with control held down to put in an entire edge loop. One here, and now we hit an issue with the bottom. I'm just going to turn the grid off so it goes out of the view. Because we cut those edges out, we now are going to have a problem drawing this in, or we could actually draw it in. We could just draw it, freehand, like so, but that's not very accurate. So we're going to temporarily bring back these edges. Oops. So just click once and then click away. Just bring back these 4 edges, and I should be able to do this in one operation actually. There we go, done. And now I can put my control edges in very easily. So I'm just going to click on the multi-cut tool, just go to object mode, click on the multi-cut tool, scale in till I'm about 10%. There we go, close enough. Then I'm going to click, hold shift, and just lock that to a 10% margin. Or there is 90%, 10% left over, of course. And just click to close, done, and then we can go ahead and get rid of those extraneous edges. Whoops, I am still on the multi-cut tool, so backspace will take away a point that you've just done on the multi-cut tool. So backspace, 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 Q to select off the tool, and let's delete these edges we don't need again. So delete edge, so shift and right mouse button. Okay, and that gets us quadded. Let's go to our smooth view, and look at that, perfect. So we managed that without adding too much extra geometry to the inside. My original cut that solved the n-gon issue of cutting here would have made us cut all the way down here, all the way over here, across the top and back down the other side. So obviously in this case, tying these together so they're in a small pole is a much more viable option. Okay, let's just do a smooth view from the top, make sure we didn't do anything to harm that. No, we didn't. Let's click off so we can get a better view. No, that's all perfectly smooth. Let's check it against the reference once again to make sure we're at the right length and the right width, or within a very sensible margin. So we are definitely spot on for the half view. Let's look from the bottom, and yeah, there's the length of the original Lego brick. We're spot on, and here's the length of this Lego brick. We are just ever so slightly out, but that's possibly the perspective on the camera, because I was using my phone camera for this, so it's not terribly accurate. But anyway, let's hide our image planes, bring back our finished brick, and the most important thing for us is that our bricks fit together. So, oops, let me bring back our finished brick. So there is the one brick. The important thing for us is our bricks fit perfectly together. So let's smooth this and let's do a trial. If we put these two Lego bricks together, they fit perfectly. And because we took the time and trouble to bevel the edges to do the nice smoothing control loops, when we come to render this later, they'll actually have that tiny gap in between that real Lego bricks do that you can't see through, because the tiny gap is caused by the smoothing of the edges of the object, exactly the same way it is in real life Lego. So when we come back, we're going to do a 4 brick and probably a 6 brick in one sitting, because these are the simple bricks and we want to get on to a bit more of the complicated stuff right now. So we'll come back, we'll do a 4 brick which has a slightly different arrangement in the center. So that could be a little tricky. It should principally be exactly the same as we've done here, but I've got a feeling that might throw a few curveballs our way. So when we've done that, we'll look at some of the more complex Lego bricks, and we're actually going to build all of the bricks for this car and put it together brick by brick the same way we'd put Lego together, so we can blow it up later on. So I hope you found this part interesting. And I hope you learned something, and I will see you in the next part where we'll finish off the last of the simple bricks and get cracking with something a little more complicated. Thank you very much for watching. Hi, welcome back. So in the previous part we looked at putting this little pole in the center of our block here, and in this part I want to go over making the different size bricks. I also want to go over doing this a little bit more efficiently, so modeling on just part of the model and then mirroring as opposed to say cutting the whole thing out. Now let's look at some image reference of a slightly bigger brick. So I'm going to go to the channel box here. I'm going to turn on the image planes. Whoops. There we go. And I'm going to bring in a different reference. Now let me just hide these bricks to get them out of the way and move this one down. Whoops, not both. Just this one, so it's back on the bottom again, and let's bring in a different reference. So let's see, yeah, let's start with the top here. So now we've got a reference for a bigger brick. Now I'm going to leave this one in place because it's going to be the same height, so that's not really going to matter, and I'm going to bring back our brick master, so Shift and H to bring it back. Now I want this reference to be about the same size as this brick, so we're always working to the same general scale. I'm going to press E, press J to lock the rotation and rotate this brick round, because we'll mirror it across this way. It'll end up being slightly easier. So let's go into our 4 view here and just scale up our reference to where we need it. So we're looking for these to be of the same size. So, we're not working with the world's best quality reference here, but we can see that if we smooth this out, this is going to be pretty spot on. Now the first thing we'll need to do before we start mirroring here, we get rid of the reference now, is to take off one of the sides, because we're not going to need it. So let's come in and just get some faces here. Now I can select a couple of faces in the center. For a quick selection, press Shift and greater than, and we should select faces from there. Now you'll see that I've still got a couple missing on the side, but if I press Shift and greater than again, I'll start to get them on the top. So this is not, you know, the perfect selection method, but it can help speed you up quite a bit. Now I'm going to take off all these faces here. Make sure I've got them all. Okay, this one. There we go, and that will cut the front off. This will ensure that when we mirror, we don't end up with a whole bunch of double faces here. So again, for the inside, because we wouldn't want double faces on the inside, I'm going to press Q to go back to the selection tool. So I should select one there, double click, select, select, double click. And again, we're going to take the same faces off the inside. So the whole purpose of this is to ensure that we do not get double faces inside the model, faces we don't want. Always look to simplify everything, so take out anything that you don't need straight away. So let's get rid of these. And now we've got a brick with nothing on the inside just yet. But these larger bricks have different poles in the middle, so that needs to be addressed too. Now we can come around here. Let's do this with an edge selection. Select this edge, Shift, double click, select this edge, and now I'm going to just move these edges out slightly, like so, and we're going to attempt to get that about level. Now, obviously using this view, you're never going to get that completely level, so let's go in here and use this view. Now, go into vertex mode, select all the vertex along here. Right, let's make sure we've got them all. So we've missed one here, which means we've missed one here as well. Now we're going to press R to scale and scale these together. Just make sure that they're completely flat. And you'll see my handle here has gone all funky. So either it'll stop going in altogether, or it will start to do this thing where it kind of jitters about. This means that all of your vertex here are all perfectly in line, which is exactly what we want. Now let's bring the reference back in just so we can check it. Okay, and we've actually got our brick the wrong way around to the reference, so let's just we can either move the reference at this point or spin the brick. So rotate J to lock the rotation, spin it 180, and we are back on reference here. So before we mirror this, there's a couple of ways we could do this. We could mirror this across. You know, we could mirror it across to create a 4 brick right now. We could cut it and mirror it across to create a 3. Various different things we could do. Before we go into that, I want to look at actually cutting the whole, though, because if we look at the bottom reference right now, so let's bring in the bottom reference. So attribute editor, and where we have the bottom here, open that up. And again, you might need to do some adjustments to the reference, although I think I made them the same size, so this should be pretty spot on. Just seems a little bit low. Okay, so if we look at this bottom reference, you can see it's got one circular bit that comes down from the middle. Now, for us, this is not really going to be quite so necessary to do this 3 times, of course. In fact, we don't even have to do it once. We can just do half of one. So, you know, you don't want to be putting in work you don't have to. And in some previous parts, we have looked at, you know, doing this all as in one piece, so cutting the whole thing out. And that's because when you first start, it can be quite difficult to visualize what you're actually going to get if you're just working on half of the model or quarter of the model. But if we look at the reference again, we can see that because it's in this configuration, we don't even need to model half of it. We could model, say, a quarter of it. So let's cut this thing, so we're only working on a quarter. So face mode, first let's cut it in half, and then let's cut it into a quarter. Okay, so now we have, whoops, actually we don't need to cut this in half because what we need is just this quarter here. So let's just cut it in half this way, and that way we only end up making this quarter of our circle, of our bottom riser on the Lego. So to do this, I'm going to use a cutting guide. So I'm going to bring in a sphere. No, not one of those. I'll bring in actually a poly pipe, because this will allow us to get the cutting guide for both the outside and the inside. So I'm just going to get this pretty much on reference here. Okay, and it's going to be scaled up, of course, but then it's a bit thick. So let's go to the channel box and change its thickness to say 0.25 maybe. Yeah, 0.25 looks about right. And subdivisions. Now, if we were to cut round this, we would have way too many subdivisions. Our model would be too complicated. You shouldn't really use the geometry if you don't need it. I mean, that's a genuinely decent rule of thumb here. If you don't need the geometry, then don't use it, because it will just make life more complicated. Now I'm going to get mine, which will be a little bit off the reference, but we're a little bit off the reference here, so it's not such a huge deal. I'm going to get mine lined up with my model. I'm then going to push this up so it bisects the model so it can be used here as a cutting guide. I'm going to turn off the reference because it's just going to get in the way right now, and we can look at starting to cut this. Now, if we were to try and start to cut here, this could be a bit of a pain in the backside, really, because of the angles and everything. So we're better off doing this on one of the cameras. So let's go to shaded, let's turn off X-ray for a start, and let's turn this to smooth shade all. And we can't see it, so we're going to need a bottom view. So panels, orthographic, bottom, there we go. And if we turn on that wireframe and that one, we can see now we can get this thing really kind of dialed in to where we need it. So wireframe on shaded, just to make our life a little easier. And this one here, these ones here. Just get it. I mean, this is only going to be our cutting guide, so we really don't need it that accurate. But let's make the cuts now. So multi-cut tool, modeling toolkit, multi-cut, and we can start our cutting here, let's say. And I think I've activated that multi-cut tool on the wrong object, so make sure you're on the right object. And let's cut once here, once here, return to finish the tool, and then cut from here to here, and that's our outer ring. Then cut from here to here to here. Okay, so that will be our cut. So let's just control hide this thing, and now we have to look at making this into polygons, because at the moment we've got a big triangle here which is no good at all. You know, we've got 1, 2, 3, 4, 5. We've got an end on here, so this one is fairly easy to sort out. I'm going to use the target weld because these are very, very close together. We can use the target weld and just weld this to this, and that makes a 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now we just have the triangles here to sort out. And this becomes relatively simple, because if we were to, let's say, take this edge out here, so hit Q to go back to the selection tool, delete edge, whoops. Now because we're just hitting shift and right click and delete edge, that's going to take the vertex out from here. So in this case, just delete. Now normally that's a bad idea because it will leave vertex behind, but in this case that's pretty much what we're looking for here. So now we've got this configuration underneath. We could obviously extrude downwards and create that shape, but let's have a look at it. Let's mirror this first. So I'm going to mirror it this way. Now I want the point here, so the pivot point. So let's hit W to move, insert, and let's put that point right there. So when we mirror, it will mirror from there over to here, and in this case over to here. Whoops. Now insert again to stop moving that pivot point around, and mesh mirror. Okay, now we've got the direction wrong, so there it is mirrored once this way. Okay, and you'll notice that this doesn't seem to have worked. It's because of this merge threshold is far too high. So 0.02 is more than often enough, and you can see now we've got the beginnings of our circle in there. So let's mirror it again. Object mode, and make sure our pivot is in the right place. So W, it is, and let's mirror again. Mesh, mirror. Okay, and this time we'll need it in the Z direction and Z axis, and once again it's in a negative direction. Now our merge threshold, we know, is going to be way too high, 0.02. There we go, and this gives us our circular part in the middle. So let's see what would happen if we just extracted this downwards. Okay, so extrude, and let's just pull it downwards. There we go. We've got 20 divisions in here. That's far too many. So divisions 1, and there we are. Now you'll see it doesn't hold its shape very well, so we need to put the smoothing in for this. Okay, and some smoothing here on the bottom, like so, and like so. Now we'll go back to just a quarter of the model in a second, but for right now we can see that that should be pretty circular and right in the bottom there. Okay, so nothing too tricky. I'll turn the grid off so we can see it, but we weren't perfectly aligned when we did our quarter, so I'm actually going to just go back before we did the mirror. Because, you know, it helps sometimes to mirror and do that test run. There we go. Okay, and we must have the smooth view on, we do. So let's come back in here. Let's bring back our cutting guide. Whoops. And bring back our cutting guide. Let's go at the bottom view again and make sure we got this lined up right. Now, one of the problems we had when we moved that over, it didn't appear to be perfectly round, and that's because we've got this vertex here that's now, you know, sitting up here. So let's get that a little more accurate. So we can do this in vertex mode. W to move it, and just move it down here, which is now going to affect the smoothing on this ever so slightly, but it will be ever so slightly. I highly doubt you'd be able to notice that. So everything else seems pretty good. Now, of course, we could mirror this and then put the smoothing on and everything, but realistically we can do that first. So again, you don't want to be working on more than you need. So let's bring in here and let's select this face and this one. Let's extrude downwards, making sure we've only got the faces we need. Extrude, pull them down. Again, we've got far too many divisions. And let's go into one of the top views here so we can get this lined up nice and level with the bottom. There we go. Close enough for this. Okay, so now let's figure out where we'd need to put smoothing edges on this thing. So we would need a smoothing edge around here to hold it here, like so. We would need a smoothing edge around here to hold it, of course, and then we would need to hold it around the bottom edges, so one here and one here, and that should about do it, really. Let's see. Yeah, that should be okay. Okay, now one problem with extruding on this quarter is we've now got some extra faces, because you see we've got no faces here for the mirroring, and we've got no faces here, so of course we have to make sure that we have no faces here too. So there are always drawbacks to, you know, whatever method you choose. Generally modeling on a half or a quarter is a bit faster, but again, it will always have some drawbacks. Nothing is 100% the best way of doing it. Sometimes it is quicker to actually work on the whole thing. So let's delete, and now that's got rid of those faces. In this case, it's a very simple thing to get rid of. So let's come in, let's double check we haven't got anything wrong. We don't seem to have. And I've actually just, sorry for the video jump there, but as I was panning around this thing, I actually just, I'm going to go back to before I did the extrusion. You're going to have to excuse me on this one. But there is one thing I would like to check out. So I'm just basically Control Z before we do that extrusion. And there's one thing that I would like, which is a little smoothing on the bottom here, which I forgot. Because when we put the smoothing control loops in, you know, it would be nice if this was a little bit smooth too. So I can actually do that here. I'm going to multi-cut from here to here. I'm going to get this as accurate as I possibly can. There we go. And these will act as smoothing loops on the ground, which will make sense in a minute. I apologize. I didn't really think of this one when I was doing it, but yeah, it's just going to make our model look a little bit better if we have some smoothing on the ground here. So let me just get that to there. There we go. And one off to here. Okay, I'm going to have to put that in slightly lopsided and then adjust it. So vertex mode, Q for the selection tool, W to adjust this one. So just slide it up here. Get them as neat as you can. As I said before, there is points for neatness. Okay, and this time just select these faces. And what happens then is when I extract upwards, this will act as a smoothing agent on the ground. So, sorry, not extract, extrude. So make sure we have divisions set to 1. And as you can see, we've now got smoothing lines on the ground. Just slightly easier to put those in first as it happens. So let's pull this down until it's level with the bottom. There we go. Job, as they say, is a good one. And now let's put our smoothing control edges back in here. So multi-cut, top, bottom. And where else we need them? We would need one here, like so, and one here, like so. Okay, and then we've got those ones around the bottom that we put in now. Again, my apologies for making you do this twice, but let's get rid of these faces. You know, it's not a big job really, so whoops, there we go, get rid of that. Do a quick spin, make sure we haven't got anything we don't need. That's a good job we checked, because there was one and there was another one. Looks like I'm all fingers and thumbs today. And delete, and now we can mirror across. And this time we should have, you know, a perfectly round one with the smoothed edges. So let's come up here, and I'm actually going to Control D and take a duplicate of this just in case we need it later. So it never hurts to have a few duplicates kicking about. Our pivot point is still in the right place, so of course mesh mirror. Put the direction to negative in this case, and again, look what happened. This is because of this merge distance. So 0.02, make sure that you don't have any merges that you don't need. Okay, we don't in this case. Okay, double check for n-gons, triangles or anything else. Nope, that seems fine. So Q for the selection tool, and then mesh mirror, and this time we know it's going to be in Z. Okay, and again this merge tool is going to be way too high, merge threshold. There we go. Let's look at this. Perfectly round, perfectly smooth. Okay, we seem to have a little geometry issue around the bottom here for some reason that I cannot quite fathom. Does that repeat? Yes, of course it does. So we must have a weird vertex or something here. Let's go vertex face and see if we've got any double edges, which will appear as just single lines. We don't appear to have. Vertex mode. Make sure these are actually merged together correctly. They do appear to be, yes. So it looks like this one might be an issue. Yeah, we've got double vertex there. See, I moved that up and no edge moved with it. So for some reason we got a double vertex. It does happen. Just check them. No, that one's fine. If a vertex comes up and no edge comes with it, you got some double verts. Could have been from a bad extrusion. Probably in this case because I used Control Z to go backwards. So I mean, it's not really an issue when you start to see weird geometry like that. Bad vertex merging or an extra vertex in your model is probably something you want to be looking at. Okay, no. Alright, so that should work now. You know, you're always going to get some problems. There we go, perfectly smooth around the bottom, perfectly smooth around the top. And we are done. Now, if we wanted to make, let's say, a 3 brick, all we need to do is, well, let's take a copy of the 2 brick first, because we're going to need that later on down the road. And then to make a 3 brick, we just come in here. This will be nice and easy. Cut these faces off. Make sure we got the ones we need. Delete them. There we go. And let's mirror this across. So make sure the pivot is in the right place. Insert, align it. Whoops. You'll see what's happened here. It's all gone completely funky. That's because we've got history on this object and it already has mirror operations on it. So when you change the pivot point, it will change the mirror operations. So edit, delete by type, history, come in, insert, change the pivot, insert, align it here. You'll see now we don't have that issue. And let's go to object mode, make sure we are on that, and then mesh, mirror, and there we go. Again, this merge threshold is going to be way too high. Done, done, and done. Okay, so if you want a 4, now of course, you just chop the front off this the same way we did with R2 and mirror it, and then if you want a 6 you could chop the front off this and mirror it, and so on and so forth. So I hope that's been of use to you, and I will see you in the next part when we'll be looking at retopologizing bricks like this for edge flow and slightly more complicated Lego parts. So thank you very much for watching and see you in the next part. Now, we're going to make a slightly more challenging Lego brick right now, and I'm going to bring up a picture of it, and it's this one here. It's a standard 2 brick, but it's got this claw thing on front of it. So this is all going to have to be made and then joined together with the main Lego brick. So let's have a look at our 2 brick, and let's add this one to our list of layers here. Finish bricks, add selected objects. And then we want our 2 brick back, so let's bring back all the objects, duplicate the 2 bricks so we have something to work on, and hide all the objects again. Now you'll notice that our duplicated brick is in this finished bricks layer, so it hides with everything else. Control D to duplicate if I forgot to say. So to get it out, we just make sure it's selected and remove selected objects. There we go, and then we can hide that lot again, and we've got this finished 2 brick. Now, what we need to do is put a claw on the front of this, but we're going to run into problems with that. Now we're going to go back to topology in this part because it's going to be necessary, but first off let's bring the image planes in for our new Lego brick, which I've cut up in Photoshop as I've done before. So let's show the image planes here, and let's grab this one and change it to the top view. So brick top, where are we? Grab brick, I think I called it. There we are, top. Done. And that's that. And then let's bring in our side view here. I think we had grab brick side, done. And this one's coming upside down, no problem. E, J to lock the rotation. Much easier to rotate it a perfect 180. Alright, so first things first, I'm going to use the top view to scale this image plane to the same size as this 2 brick. So let's come in here and use this top view. So let's just move it for a start and get it about right. Okay, so it's far too big. Let's scale it down, and it seems to be a little off kilter, so let's just, a lot of that will probably be to do with the camera I'm using, which is just my phone camera at the moment. My main camera is actually out on loan. And let's get this reference to about the right size. So somewhere around there would do the job. So as you can see, we've got this claw component that comes off the front and then also has this kind of depth to it. Now, we scaled these image planes to the right size in Photoshop, so if we select this top image plane here and go under the channel box and see what we scaled it to, 0.804. So let's just copy that. Let's go into the other image plane and under scale, left click and drag down and then just paste that into one and it will paste them into them all. So we know this is now in scale, so all we have to do is get it in position. Now, we don't seem to have a good position for this. So I can either flip this block, which is a little bit annoying, or I can simply rotate this to match the rotation of the block, which is far easier. So rotate that. You can see here it rotated 180. And let's get this scaled. So let's turn off X-ray, which we have in this view for some reason. Okay, and then I'm going to move this up until this just kind of bisects here. This one looks absolutely fine. It looks to be the right scale and in the right place. So now we can see that we have this claw that comes off the top view here and the side view here. Problem we have is this 2 brick is too big. This 2 brick should only be 1/3 of this size. So just grab the bottom and move up until we hit the bottom of the reference. Now, because our references are really not perfect, we need to make sure that this fits in with the size of our other bricks. So bring our other bricks back, and one of these bricks should be 1/3 the size of one of these. So if you build Lego, 3 of these stacked on top of each other come to exactly the same size as one of these bigger bricks. So if we duplicate, Control D, and move this down until it's at the right point, and I'm going to do the wireframe unshaded here so I can see the right points. I can see that gets to the bottom of the brick, and then Control D again, and it's gone right off the bottom there. So these are slightly too big for us. So I'm going to Control Z back until I have one brick. I'm going to select the vertices. I'm going to move that up just a smidgen. There we go. Just a tiny bit. And did I actually get all of them? Let's Control Z that. And let's actually move this out of the way so we can select the vertices properly. Like so. Move them up a tiny smidgen, and now that should be the right size. Let's just double check it, never hurts. So Control D, move this down until they're kind of perfectly aligned. There we go, Control D, move this down until they're perfectly aligned. And now, of course, it's a smidgen too small. So we could get the measuring tools out, but for something like this, generally I prefer to eyeball it. It's quicker. Control D, here we go. So just so it's just barely breaking apart. Control D, so it's just barely breaking apart. Okay, and we are, so close now. This normally only takes me one try. I'm not sure why this is being such a horrible thing to do at the moment. But so a tiny smidgen, yeah. That'll do it. Pause for verification. Just a little bit, and just a little bit, and we are perfect. Okay, I've left a little bit too much of a gap here, so let's go upwards a bit, and upwards a bit. Now we might be slightly off the reference, but to our scale, we are now perfect, and that's really the important thing here. So sorry that took so long. Normally it's a much quicker process, but sometimes you do need to fiddle with the value a little bit. It depends on how accurate you'd like to be. So I've got my duplicated Lego bricks here. Now I've got the original Lego bricks, which we'll go ahead and hide because we don't need them now. And I'm going to get rid of this one because it's the wrong size, and I'll move this back into line with the reference. There we go. So what we need to do is look at pulling this claw shape out. You can see this shape. Let me just move this one down so we're looking at it like so. So this is not going to be a terribly difficult shape to make. I mean, it is just a cylinder with a hole cut in it. The problem stems from the fact that we have to join it to this object, which should be easy. We'll cut a face, an edge here, cut a hole and join a cylinder to it. The problem comes from the fact that if we cut an edge here, we're going to end up with n-gons, which we can't have. So if we cut a whole edge loop, this happens. We get an edge that goes all the way across the top of our Lego knobbly bits here. I'm not sure what they're called, but the Lego stick-up bits. And if I hit 3 to smooth, you should be able to see that our smoothing is now all gone to pot. Look at that. That's hideous. It's got a big bump in it, as you would expect, because it's got a big edge in it, which is going to control the degree of smoothing. So we can't do that. So what can we do? Well, we could cut an edge in here and then join it here and have a big triangle. And again, that's not always that bad. Sometimes you need to. Most of the time you don't. There is a way around it. Now, if we look at this model as a whole, the topology of it is fine for our purposes, but it could be better. And this is one of those cases where you've got to sit down and think about edge flow, because our multi-cut tool is cutting straight across the top and straight towards the middle. And that's because of this edge flowing up here. This edge with the multi-cut tool then follows it and ends up going all the way up the side here, across the top, down the side here, up the side, down the side. So we would be much better off if these edges didn't exist and they were more in squares. So these are quads, but they're not very square, they're not very even, and they are coming to poles, which, as we mentioned, poles are never a great thing to have on a flat, non-deformable surface. You can get away with them, but again, they cause edge flow issues. So now is the time to really sit down when we get more complicated Lego bricks, like this one we can see here. Now is the time to sit down and really think once again about object topology. So I could start by removing these edges. Now I'm going to turn on symmetry when I do this, so I'm going to go to the Move tool, go to the symmetry settings, and turn symmetry on world Z. Because look, this is Z, Z this way, so when I select this one, I want to select that one, so on and so forth. That way I can work on half of the model. I'm going to go to the modeling toolkit and just select edges, which you can also do right mouse button edge, same thing. And I'm going to get rid of all these edges here that are coming to these points, to these poles. So let's get rid of all the edges that have poles. Okay, and we'll need to do the same thing underneath, so we'll need to turn off the image planes for this. And you can quite easily see which edges here are coming to poles. So this one and this one and this one and this one. Now, Shift, right click, delete edge. Now, we've got cleaner geometry, or at least it looks like on the surface, but again, n-gon, 1, 2, 3, 4, 5, 6 sides. So we've got rid of the line here, so we need to do something else with it. And in this case, we're going to run it down and around the model, so our edge flow gets better and gives us another edge here to attach our claw to. So, modeling tools, multi-cut. First thing is just to cut the edges here, and cut them here. Get them as straight as you can. So we're probably going to look at that in the top view, because we want these nice and straight. So I'm going to backspace to undo that last cut, and it doesn't matter which side we do this on. We just want to make sure that it's nice and straight. Okay, so that didn't come in 100% straight. I find it quite difficult to see the multi-cut tool sometimes with that green line it has. So we're just going to come up and use the Move tool, select the vertex, because symmetry is on. It will select this one over here as well. And we should straighten those up. You know, we don't need to be hyper accurate. That will be good enough. So now we've got rid of the n-gon here. We still have one here. 1, 2, 3, 4, 5. So we're going to have to cut this way too. Okay, let's get that straight, or you know, straight enough, and that's pretty straight, pretty straight. Okay, so that's got rid of the n-gons on the top. We're all quads again, and we don't have the big pole issue here. Now we have to do the same here. Get it straight as you can. There we go, done. And again here. This is where we had one line before connected into a triangle terminating in a pole, where we're going to get instead these nice squares. So let's click here, and this time let's jump across straight to that one. And I've got symmetry on, remember, so it's going to do both sides at the same time. And then we have to go from here to here. and from here to here. And last one, well, last cut on the top at least. We have to do the sides as well here. So look at the topology of this model. It is slightly better. We don't have any poles on it now. We have much more uniform squares, which to help with smoothing. We have introduced extra geometry though, and that can sometimes be a problem if you're trying to keep your work very low poly. But in our case, we're not. This is more than low enough poly. And if I smooth, you'll see that's had very little effect on our smoothing. If anything, it probably looks slightly nicer. So, now, we've done the top. Top is absolutely fine. Square, 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 square. Squares as far as the eye can see. Absolutely lovely. What we are missing is all these edges that continue on around here. And we also didn't do the bottom. So we're going to have to work out a plan for the bottom as well. And again, it's going to be a very similar kind of plan. We're just going to cut here and cut here. And again, with symmetry on, this will do both at the same time. So saves us some time. And here to here. And that should do it. And that should do it. Now, let's check this out. I think we're going to need... Yes, we are. We're going to follow this edge around to where it would end up normally here. So here to here. And here to here. Now, we could have done some of this work before we duplicated this object over, of course. But sometimes you just don't know what topology you'll need for a given circumstance. So it's a very, very handy skill to be able to recognize when you need to retopologize on the fly. Now we should have enough edges down there and enough up here. It's time to cut here. So let's use the multi-cut tool. And I'm going to flip back to object mode, hit multi-cut, and let's click here. That gives us an edge we can connect that to, and if we look underneath, there's an edge to connect this to. So that's now perfect. And that's now perfect. Now, we haven't quite joined all this up, but look what happens now if I run an edge loop down the middle. Look, it's not going all the way across the top of this anymore. Now we have a better edge flow, so when we decide to put our claw in here on the front, we'll be able to cut controlling edges for it that'll nicely skim around the center bollards without going up, over, and breaking all the smoothing. So topology, extremely important to know why you're doing what you're doing, and also very important to be able to look at an object and go, okay, I need to retopologize this at this point, because a lot of the time you do. A topology that will be absolutely fine for one thing isn't necessarily absolutely fine for another. So let's just cancel the multi-cut tool and use an edge loop. So I'm going to get this as kind of close as I can here. Done. And we're going to cut across. Done. And that should link that entire edge up down to the bottom to be linked with this one. Okay, the bottom I'm not terribly concerned about if it's that straight or not. We're not going to see that much of the bottom, and it can always be sorted out in a little while. So again, another edge here. And that was poorly placed, so control, and that looks a bit better. So just connect those up, return, and we should have somewhere to connect this up down below. Which one, I ask myself. Okay. Yeah, we've got an issue in the bottom here, so I think I'll connect it to this one. And then I can probably get rid of this edge. 1, 2, 3, 4, 5. No, I can't. Okay, let's just move this vertex a minute to get it more even. And can I cut across here? Yes, leaving myself a triangle, but leaving 4 sides. Okay, I'm going to sort that triangle out in a minute. It's on the bottom of the model, and I don't think it will affect the smoothing or the deformation. No, it won't. So we can come back and most certainly sort that out. But right now, let's just progress and get the rest of this done. So multi-cut here. If we end up with one triangle after all this retopology, we've done pretty well. Let's just place that again. There we go. Connect it up. You can see with the symmetry on, we're still doing the other side at the same time. And then we have this one to go here, which possibly will connect in here. Yes, it will. Okay, that's going to give us that triangular problem though. So could we connect it in here? 1, 2, 1, 2, 3, 4, 5. No, that's no good. Okay, we're going to have to come and take a bit of a better look at the bottom here, because now we've got different topo on both sides, which is 1, 2, 3, 4, 1, 2, 3, 4, 1. Okay, this worked without the triangle. So yeah, we just need to set this one the same as this one, and that's easy to do. If we've got one side that's perfect, we can always just chop the model in half and remirror it. Now, there is no point spending time. If you figured out a solution for one half, then you figured out a solution for both halves, basically. So let's put this in here and cut it. There we go. Alright, so we seem to be missing some edges here, but that's fine. Let's just do that now. So get them in, get them straight. There, that looks pretty straight. And on the top view, how's that looking? Possibly not quite straight enough. No, let's grab a vertex, hit W, and straighten out. Done. And edge loops. So multi-cut and hit Control. There we go. Just join these up. Again, I'll take my time and straighten this up a bit more, but on camera, you know, it's not that interesting to watch me get everything perfectly straight. And there we go. So we are retopologized apart from that triangle on the bottom. But let's have a go. Let's do the multi-cut tool, and now whack, I can put a line in, a line in, a line in. No worries, we don't go over the top anymore because we've redirected the edge flow. So there's topology to get rid of n-gons, there's topology to get rid of triangles and poles that are not as important as the n-gons, although still can really screw up your model, and there's topology to redirect the flow of edges. So you know, if I hammer nothing else into you in this tutorial, it's please pay attention to the topology. Okay, so what's the difference between these two halves? Aha, I see here. This one is not fixed because now there is an n-gon here. Okay, so how do we fix it? Okay, so I've been having a quick look at how you would fix these triangles over here and these n-gons over here, and there is a few things that spring to mind. Now, occasionally you're going to have to think about this stuff. Edge flow is not always obvious, and neither is where to retopologize obvious. I'm going to, at the moment, select both these edges and delete them, and then I'm going to join them up into triangles like they are over here. And I know we're attempting to get rid of those triangles, but this should make sense in a moment. Like so. So this is four-sided, this is four-sided, and this is three-sided. So a nice easy way to do this is to click here, and then here. And what we end up with is four sides, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So we get rid of that triangular issue. Now, it might not be the neatest way to do it, but underneath that should be absolutely fine. Let's select vertex, and let's just make this a bit neater, shall we, and a bit more quadded like. There we go. And this side down here, pull it out a bit, straighten it up. And there we go. So that is one possible solution for the retopology of the underneath. There will of course be others, there always is. There's 101 ways to do it, but we are fully quadded right now. The geometry underneath, it's fine, it shouldn't have any smoothing issues, it doesn't, it looks nice, it's all quads, we got rid of the triangles, and we are perfect on the top too. We have managed to redirect the flow of edges. Let me just go into object mode and multi-cut. So now I can cut in here on the outside without that becoming an issue of cutting across the top. So let's do a comparative look at our original Lego brick. So we'll go in and we'll go to the channel box and hit visible on finished bricks. And I'll just hide a lot of these, the 1 brick and the 6 brick, or the 8 brick, sorry, 2 times 4. And we can see now the difference in topology on these 2 bricks. Now, this one is perfectly acceptable. If I was just, whoops, I hit 4 on the keyboard for wireframe view. If I was just simply going to build a Lego brick that had no attachments to it, I'd probably call it a day on that one. However, because we're going to need in the next part to cut in this sort of claw arrangement and attach it to the front of the brick, for us this is a better solution. The edge flow on this is not very good for that. If we take again the multi-cut tool and we wanted to cut these 2 faces here, and we did cut, what we've done is cut straight across the top of all our geometry, and of course when we smooth, that's going to have a complete conniption. It's no longer round, because we no longer have an even number of smooth edges. Whereas this one, we've got our holes here, we've got room to cut in extra geometry with no problems at all. The edge flow simply redirects around the center posts here on the Lego brick, and we are absolutely fine. So there we go. We've had a look at topology for getting rid of n-gons. We've had a look at topology for getting rid of triangles. We've had a look at topology for getting evenly spaced edges for the smoothing, and now we've had a look at topology to redirect edge flow. Okay, so I just turn the wireframe and shade it off there. You'll see that these both look on the surface of it quite identical. So, there's a million ways to get this shape in Maya, some easier than others, but there are correct ways for doing it depending on what it is that you need to actually add to it. So I'll be back in the next part when we'll look at actually putting the claw on the front of this thing. So I hope that's been of interest. I know topology and edge flow can get a bit dull. We want to get on to these sort of fire-breathing dragons, but without decent topology and edge flow, you're going to make more fire-breathing chickens, really, that nobody else is going to be able to work on. So getting this stuff down pat right when you start Maya, right out the gate, is extremely beneficial later on down the line. Thank you for watching. I hope you found this interesting. Hi, welcome back. So we finished off the last part with our retopologized Lego brick here for better edge flow for what we're about to do now. And if I flip on the image planes, you can see we need to create this piece of geometry here. Now, there are a variety of ways to do this. We can do it with a polygon. Let's see, you could do it with a poly cylinder. You could do it with a poly pipe. You could even start with a straight box, add a geometry, cut it out and move the vertices around. But as we're doing a tutorial here, a lot of the time for something like this I might use a curve, because this is a very curved surface, so we could just draw it out with a curve and look at different ways to get that into a polygon from there. So I think for this part of the tutorial we'll start to look at curves now. I think we've had enough of polygons for a little while, so let's take a look at curves. So we're going to go under curves and surfaces, and you have various different ways of drawing a curve. So you can use the EP curve tool, which just takes 3 points and puts a curve in between them, and as we continue to draw, it then averages that curve out. And this can be fantastic for certain objects because there's very little work to do. I mean, literally you just click the points nearest that you want and it tries to work the curve out the best it can on its own. Now, of course, if we click enter to finish that curve, you can come in on polygons that are called vertex, on NURBS and curves, control vertex. We can grab this control vertex and straighten things up shift them around, try and get the curve more into a shape we like. There we go, like so. And then of course you need to bring the bottom up, and you've got a pretty close representation of what we see here in the reference. So you could do it with an EP curve. Just press enter. Oops, get off the curve tool. There we go. And there you go. So pretty close representation. That's the EP curve tool. You then have the freehand curve tool, which as it sounds just lets you draw freehand. Now if you're on a tablet and you've got a very steady hand and you've got a very complex shape to cut out, this tool can actually give you fairly decent starting point. And let's just join that up like so, and there we go. Now there are ways you can automatically get less curve points on this, because if we have a look at it, let's go to Q and Control Vertex, you'll see they're all over the place. It just draws one, you know, every time the pen direction changes basically. So you end up with a very high CV point curve doing it that way. Sometimes it's necessary, and you can reduce the number of CV points by simply going to Surfaces, Rebuild, setting a more sensible number of CV points. So let's say, yeah, let's just use the standard options. So reset settings, and I am on the surface rebuild. I need to be on the curves rebuild. Sorry, curves rebuild. I thought the menu looked a little strange. Number of spans 12, and that gets us back to 12 CV points. So there are ways and means to minimize the effect of that freehand drawing. But for us, this is not a complicated enough part that needs, you know, lots and lots of freehand drawing. So we're going to use the Bezier curve tool, and it works on a very similar principle to the pen in Photoshop. It's also the most difficult curve tool to use in Maya probably, which is why I'm going to show it to you. It's one of my favorite curve tools in Maya. It allows a great deal of flexibility as soon as you get used to it, you know, somewhat like the pen tool in Photoshop. So we're going to click here for the first point in the Bezier curve, and then click here. Now when we put the next point down, we're going to click, hold the button down and drag. So I'm going to click, the button on the mouse is still down, I'm going to drag this out, and you see we drag out curve handles that we can use to get this to match the reference. So another one here, click, hold and drag, and match that reference. Now you might need to come back in. This one might be a bit lopsided, so if you click on it, and again if you click here you can move it around. If you click on the handle, then obviously you can pull that handle out a bit more. So let's continue. It will continue on from the last point. We'll come in here and click the last point, then come in here, and we know that this one is going to be a bit tricky because we're going to want to go straight down. So we've got a kink there. We'll go back and edit it later. And straight across here, slight curve maybe, down to here, curve in the other direction, which is going to cause us problems because then this one is going to need to be set in a different, there we go, lovely jubbly. Click on the end point, click on the next one and the next one, and just keep going round really. Pull your handle out, get the shape you want. You can come back in and edit any NURBS curve the same way you can do with the polygon. So if you don't get this right on the first try, you can come in, you can change the control vertices around, you can go back to points like so, change the handles of them to get a better look. You know, it could be that the handle on this one needs changing. Now you see when I click this one, I didn't actually click and drag, so I've got no handle. But if I press Shift and right mouse button, I can go up to Bezier and that gives me a handle. So perfect. Click this last point, click up to here, get that about right. There we go, and we know we want a fairly straight finish. So to close a Bezier curve, you need to hit Control, Shift, and click on the starting point, and that will close the Bezier curve. Before we close that, however, let's do a bit of editing here. I'm not entirely happy with this shape. There's a definite kink here, so let's click this one and make it straight like so, get it more centralized. Same with this one, not happy with it, so let's, and don't reverse the direction of your curve because you're going to end up with a very strange shape indeed. Okay, and you want these two here to be about equidistant, We're going to try and keep these kind of organized if we can. So 1 to 1, 1 to 1, 1 to 1, 1 to 1, and 1 to 1. So all of these in a line. Obviously that's not always possible, and you don't need to be too fastidious on it, but the same with everything else in 3D. The more uniform you can keep everything, the easier it's probably going to be at the end of the day. So we have no Bezier curve on this one. We have no handles. So again, just shift and click and Bezier, and that will allow me to then do this, which gives me a more rounded part at the front. So I'm in a pretty straight line here. I've got one extra here because I don't need them there and there. These are in a pretty straight line. This one is very strange indeed. Let me just see if I can straighten that out. So straight down one edge. Let's check this handle out. Yeah, that's not good. So that's much better. Let's see if that affected the top. No, it didn't. So that's much more what I'm looking for. Let's try and match that reference a bit more. Come in here. Okay, that's looking a bit better. So we could do a better job of matching here, I guess. Let's pull this in a little bit. I probably need to start adding more points there. There we go, I can push it this way just a little bit, flatten that out a tad. Okay, I'm going to press Q to come off the curve tool, and I've got something that's gone badly wrong here. You can see it. So I'm going to press Ctrl Z to go back to when I was editing the curve. Whoops, that's made the whole curve disappear. Let's go to the control vertex. And yeah, I've got, I think, 2 points in here. So something there has gone very wrong. Okay, and obviously this should be a straight flat line. There shouldn't be any thickness to it. I'm just going to go in the perspective view and figure out what went on there. Yeah, so at some point I've clicked twice when I meant to click once, and we should be able to Bezier curve tool. Should be able to just go back in and look at that. I've got an extra point. I'm going to hit delete. So if you need to go back in and edit the whole Bezier curve, there's a very simple way to do it. You just press shift and go back to the Bezier curve tool, and there you go. So you can come back in and edit a Bezier curve. Quite like that about them. Whoops, and I've created a new one by accident. Okay, so we are done. Now we have this curve. It's in the shape of our component, but as you see, it has no depth to it at all. So what we'll need to do is create another curve over here. There's the edge of the component and loft between the two surfaces. However, before we do that, if we take a look at the control vertex on this, they're quite evenly spaced. They're not bad, but we can do a little better than this. So if we wanted truly uniform spacing on these, for when we convert it to a polygon, uniform spacing is going to be easier for us to work with. What we need is to convert this Bezier curve into a standard NURBS curve, so we can use the standard NURBS curve tools on it. Now, it might be better off to keep a copy, so Control Duplicate and Control H to just hide the copy of the Bezier curve in case anything goes wrong, which, being Maya, often does. And then we're going to convert this from a Bezier curve to a standard curve. So hotbox once again with the space bar, and you want to go to find the modify, convert, Bezier curve to NURBS. And we're just going to click that. There's no options for it. That's now converted it. When I go to CV points, you'll see that I no longer have Bezier handles. I just now have a standard NURBS curve. And to get this a bit more into shape, we're going to go to Curves, Rebuild Curve, pop open the options. I'm going to reset this to default. Now by default it will try and rebuild this with 4 spans. That's going to be too little for us. Let's see what happens if we try it with 8. Apply. We lose way too much shape. Control Z to undo it. So let's try 12. Apply. We still lose a bit too much shape, but we could probably reshape that a little bit with adjusting the CVs, but we'll go a little bit higher up to 16 and apply. We lose some shape, but it's not that bad. So if we look at the control vertex now, they should be fairly evenly spaced around. And if we want that exact shape back, we can go in and do a bit of tweaking here to get this line to straighten up a bit. There'll be some hidden ones in there. So we want a nice straight line along the back, or you know, as straight as it will go, being a curved surface. And again, we're going to match the reference here. So this will allow us to create the polygonal geometry a bit easier, which is, you know, always a plus. And you don't have to be exact, because we can come in and obviously modify the polygon at the end. But as with all things, a little bit of extra work here goes a long way later on. So make sure this is nice and even. You're looking for a nice kind of sweeping curve line, a little bit straighter at the front. We're going to need it, I feel. There we go. And this is a bit bulbous down here. Whoops, lost my CV point. There we go. Okay, so we get a nice even curve. I quite like it. It's possibly a little bit too thin there. Let's pull it out. And we're done. So we've gone from a Bezier curve to a standard NURBS curve. Now we're going to duplicate this because we need another one to loft between. So Control D and move this one out until it's on the reference line there, which as luck would have it, I got that perfect. Okay, so we've got two NURB curves now. Let's select them both. Go to Surfaces, Loft, pop open the options, reset them to default. And what sort of surface do we want to build? Well, output geometry, we want polygons. Okay, so we want to output in quads, and standard fit will normally do, and hit apply to loft across. Now this has created a bit too much geometry for me, so I'm going to Control Z that, and I'm going to go to count, which would allow me to tell it to use a specific number of polys, or I'm going to go to control points and loft. So in control point mode it does this, which looks like it's not matched at all, but if we smooth it you'll see that it indeed has matched quite well. Now it's brought with it some extra geometry. These lines here we're not going to need. It possibly has too much geometry here in the center, although maybe not. But other than that, it's quite a nice shape. You'll notice it's backwards, it's reversed. The black faces are on the bit that we would consider the outside of the model, and the grey faces are on the bit we would consider the inside of the model. This is not a problem. We just go up to Mesh Display and reverse them. So that's reversed them. So now the inside is on the inside of the model and the outside on the outside. Let's just grab these edges here, 1 and 2, by double clicking, Shift, right click, delete edge. That gets rid of the extraneous edges. Now it's easier for us to work in unsmoothed than it is for us to work in smoothed. And let's see about getting rid of maybe some extraneous edges. So we've got an extra one here that I don't think we're going to need, so delete it, delete it. For some reason that is not deleting. Okay, can I delete this one? Yes. So in that case we'll just move this one up a bit. Okay, that's why we couldn't delete the edge, because it's an open edge. So we obviously had a curve that wasn't precisely closed. Again, not much of an issue. We just use the modeling toolkit to bridge across the gap here. So Q, select this edge, select this one, and bridge. And there we go. And now I should be able to take this edge away, delete edge. Now I've got two edges in there. I've got one down here. I think I'm only going to need one. This is fairly straight. So let's take this edge and delete. Simplify being the name of the game here. The simpler we can get it, the easier this next bit will be. Now we know that the back here is straight. So let's go to a vertex selection, which you can either right click and hit vertex, or you can just click it up here in the multi-component menu. Select these, R, scale them together to straighten them up, and job is a good one. Now we have a point here, but no corresponding point there. So select the edge, and we're going to use a new tool, so Shift, Slide on Surface, Slide Edge tool. Okay, now I can drag the middle mouse button, slide the edge up and down. So I'm going to slide it about there. There we go. You could have also just moved it. The slide edge tool is more useful when you're moving multiple edges in different directions, and we probably will demonstrate that at some point. Okay, now let's fix this up so it has some sort of front on it. Now, we've reduced the number of polys required to make this component quite drastically, but smoothed, it still looks mostly like the original, and we'll sort out the mostly part in a little minute. But for now, let's just use our bridge tool. So edge, we want this one, and they'll bridge together quite nicely. This one and this one. Let's make sure we get the right one here. Bridge, they'll bridge together quite nicely. These should bridge together quite nicely. Bridge. Now we're going to experience problem. This one and this one will bridge probably. No, this looks very simple actually. Bridge, bridge, and finally bridge. Now that's the joy of working with extremely simple geometry, because when we come to do the things like putting the sides on this, so we're actually retopologizing this model for the sides. We're adding geometry to it in order to make it quadded geometry here. So 1, 2, 3, 4. We're all quads, I believe. Let's use the multi-cut tool and see if we can cut an edge around. We can in every direction, so we're absolutely fine here. Because we made this simple to start with, we now have a very simple job of doing this, and you can always add more geometry later if you need to define the shape more. Now, talking about that, let's mirror this across, because at the moment it is only half the size it needs to be. So let's look, we are in Z, I believe. Yeah, so we're gonna, Z is this way, so this will be negative Z. Now we'll need to put the pivot point somewhere up here. So let's go to W and insert to move the pivot. Let us snap to points and throw it here, should do. And then mirror it. So mesh, again the hotbox for spacebar, mirror, okay, and that's in X. We need it in Z, and negative Z, there we go. Now make sure this merge threshold is not too big. In fact, this is so simple that this would do, but better to get into the habit. And object mode. And now we have one object. So these NURBS curves now are superfluous to requirements. They say Bezier, but you can see the different icon in the outliner. These are actually NURBS curves. This one, the hidden one, is the Bezier curve. So before we just delete those, we're going to delete the history on this, because as you can see, when I select these curves, this goes purple, and that's because all of these things are still connected to each other. So if I took the control vertex from this curve and started moving it around, you will see sometimes, depending on how it's connected, this will have an effect on the polygon geometry. It doesn't appear to this time. Let's click that and point off. But regardless, when I click it, it highlights purple. So it is still connected in some way. It's not changing the geometry at this time, which is quite unusual, but it doesn't matter for our purposes. What matters is that we still have a live connection between the two that we really don't want. So I'm going to go to Edit, Delete by Type, History, and then when I click one of these curves, you see it no longer goes purple. I am now safe to delete these curves without the risk of my geometry here disappearing. And we're now safe to go on and shape this into this shape much more. So if I smooth it now, it will completely collapse in on itself. Before we look at that, we're just going to do some basic shaping here with the vertices. So let's get some basic shape. We know we want these front portions fairly straight. Okay. Right, that's going to be too high. Let's move this one up a little bit. And let's move this one up so it's in line here. Where do we want it? Right on the top of the box, I would think. So this one, just to straighten it up. As you can see, we're just pulling these back in to match the reference once again. Now we don't need to be perfect because the smoothing will take care of a multitude of sins. And I'm clicking and dragging. I'm not just clicking, because if I just clicked, I wouldn't select the vertex points behind this one. So again, click and drag. And let's smooth this and see what it looks like. It's pretty close. We need some control edges in to stop it completely collapsing. So let's sort that out. So multi-cut, let's cut a control edge in this way. And this way. Where else are we going to need them? We're going to need one around like so. And the same on the bottom. And then we're going to need, on the other side, I'm just going to hide these image planes because they're now getting in the way. On the other side, again, control edges, as we've done before, just to control the level of smooth that this thing undergoes. Because, you know, Lego is always going to be somewhat smooth. I think the Lego company wouldn't have any, you know, sharp, pointy Lego bits for the children. Okay, and that should just about do it. To object mode, there is our claw. That should match our reference pretty well. Let's bring it back. You know, it might not be absolutely spot on, but I think it should be wrong view. Well, we can see from the top that it matches, and from the side, yeah, I mean, it's almost perfect. You could indeed spend some little extra time tweaking that exactly into place. Okay, just a little bit more exaggerated there. Possibly pull it back here a little bit. But you know, guys, this is pretty good. You know, I would most certainly be very happy with that. Looks like the original component to me. Now, what we've got left to do is connect it to this box. So we're going to have to cut some holes in the box, and where these lines are, this is going to have to attach to this. So we're going to have to draw more lines across the surface of this, which is one of the reasons we retopologized it. So when we draw those lines, they don't go straight over the tops of our, you know, stick out bits here. I'm still not sure what they're called, and ruin the smoothing on this cube. But for right now, let's just push this so it bisects a little bit and smooth it, and let's take a look at that. Okay, so when they're joined together, you'll see a nice smooth between these edges here. And we have one more complicated Lego brick, I would say. It required some edge flow work done on it. It required some NURBS to do this. I mean, we could have done this with a polygon. Again, myriad of ways to do things in Maya. Certain people like certain ways, other people like, you know, a different way. And I think I just spotted in here, let me just check, base mode. So 1, 2, 3, 4. No, we're still a quad. But this pole here is not too wonderful. But again, because this is never going to be a jaw that chomps together, it's never going to be a concern. So, you know, as an exercise, you might want to think of a way to tidy this up a little bit. I can think of several, so it's not quite so packed together. But for practical purposes, this is really low poly at the moment, so I'm not going to mess with it. I quite like the fact that it's so low poly. And final check to make sure we didn't get anything wrong. No, that looks pretty good to me. So in the next part, we'll come in and we'll connect this box to this box and make them one complete object. So thank you very much for watching, and I hope a quick look at those NURBS curves has been interesting for you. Hi, welcome back. So we left off with our block in this state as two entirely separated objects that need to be made into one object. Now before we can do this, we need to take off all the faces we don't need, because if we were to stick this and this together, like so, we'd end up with a bunch of faces on the inside of the model here that we don't actually need. And you don't want to do that. That will interfere with smoothing, it'll interfere with your geometry later on. It's just very bad practice. So before we start cutting faces out of this, let's look at what we actually need to join up here. So if we look at this from the top, and we look at this from the top, you see we could connect one edge here, one edge here, and one edge here, but we're missing an edge here and here. Now, we went to all the trouble of retopologizing this, and I still have symmetry on in Z, so when I select one, the other is going to select as well. Now, we went to the trouble of retopologizing this for one very simple reason. So we can fit these pieces together with very little fuss. So let's come in and let's look at the top view and get these kind of close together. So we want this edge to marry this inside one. So in order to do that, let's move this a bit closer. We can come here and reselect that edge. So we're going to have to, yes, thank you Maya, I know. Just go back to edge mode and it will be reselected. Then from the top here, we can move that in to exactly where it needs to be. So we're going to marry this edge to this edge. Okay. And what we've got here is this is not perfect, going straight down like so. So let's grab vertex and move this one and try and get it a little more harmonious. There we go. Just so we don't have that straight right angled drop off there. Now we're going to need another edge to marry up here. So let's use our multi-cut tool. And because we have this edge flow now, we're not cutting through the middle, of course. So let's marry it up there, and it's mirrored, so it's done automatically on the other side, and that looks like a pretty close fit. Now let's look at what other edges we're going to need. So this has an edge here that it will marry up to this smoothing edge here, and this edge here will marry up to this smoothing edge here. Now in order to achieve that, we're going to hit edge mode on this object, select this one, and move them up a bit so they're more in line. Actually, I'm going to have to do that one at a time. I could change the mirroring symmetry to Y, and that would have done them both at the same time, but then I would have needed to have come in and done them on this side. So either way, we were going to have to do that one at a time, and then back to our side view, and this edge, this edge, this edge, this edge. Now we simply need three edges here. So multi-cut, 1, 2, and 3, and they're pretty spot on really. So these should join together now with no issues, and we haven't ruined the topology of either in doing that. So reflowing these edges, redoing this topology on the part 6 or 7 of the tutorial, I think, was worth doing because now it's made our life really easy. Let's come and move this away, and we need to delete all the faces from the back here. Now you'll see here that this is not very nice, but that's not going to matter because all of these faces are being deleted. Okay, so that's all of those. Delete. Now we've got that open. Now we need to go and open this as well. So face, holding shift of course. Delete, and these components should now fit perfectly together. Now a few ways to get these together. We could do it with an edit mesh on the hotbox and merge, and hope that they merge successfully. This way is a little slapdash for me though, and there's not many edges to join together here. So before we do this, I'm just going to sort the bottom out because we didn't look at that, and these vertex are just not very nicely placed. So let's come in, straighten them up a bit like so. Actually, they can be a bit straighter than that. There. That just straightens out the bottom, make sure we've got everything nice for the final merge. Okay, and before we can merge, if you remember, as we originally did with the original cylinder and box to create this, we need to combine these objects before we can start actually merging the vertices together. So mesh, combine, and that actually worked on the first try this time. Great. So now a couple of options to combine them. Like I say, you could do a edit mesh merge like so, and you'll see as we raise this merge threshold they'll actually snap together. So let's try a 0.1. It's probably way too many. Yeah, 0.05. And there you go, everything is merged. So that's the very, very fast way of doing it. The problem is that we can already see this has got some issues because these were too close together, so they've merged. This way of doing it is, it's a little hit or miss. It's great if you've got vertices that are very far apart all over the place. Not so good if you need a bit more precision. So you can go in and do this one at a time. You can select the vertices, you can select this vertice and go edit mesh, merge, and that will just merge those two connected vertices there. There you go. So you can do it that way as well. That's not a bad way of doing it. You'll notice they merge towards the center there, which is not exactly what I want in this case. What I want is for them always to merge to this back one. So for this we can use one of the modeling toolkit tools called target weld, and we're going to grab the verts on the claw object, not on the Lego brick object, and we're going to go click and drag over to that point, and that will target weld them together. So we just go down, and you know, if you've got thousands upon thousands of vertices to merge and they're a very short distance apart, then a simple edit mesh merge will work perfectly. In our case we don't have that many, so it's not a big chore, especially since we have the symmetry on, so we only actually have to do one side. And look at that, we are pretty much done already. Okay, so 3 ways to do it. You can try and do it all in one go if your geometry is very tightly packed and you've got lots of vertices right on top of each other. That could work for you with a very small merge threshold. You can do it by selecting the individual vertices and selecting edit mesh merge, or you can use the target weld. In this case we went for target weld, but you know, depending on the situation you might use something else. Now look at that. We have here nice topology, object that's solidly joined together. You can see now, if I turn off the wireframe unshaded, that these edges are nicely beveled in, so it looks like one object. It doesn't look like one object in Maya has been shoved inside another object in Maya. It looks like one piece, because it is one piece. Now, something I would say about that, if you are modeling an object where the things would obviously be 2 pieces, like table legs on a tabletop, that's going to have been 2 pieces that are screwed together. In that case, a mesh combine can work quite well. It can add some realism, because you wouldn't expect the legs of a table to flow in to the tabletop in quite the way that this is doing here. But this will be a Lego piece, it will be injection molded probably in plastic, so it will be one contiguous piece. So you should look to make it one contiguous piece. And that is it for this particular brick. That worked out rather well. I think it matches the reference pretty spot on. Let's have a look. And I've hidden the reference, excuse me, so Shift H to bring it back. And let's have a look. Zoom out here. So it matches the top of the reference. Okay, we're a tiny bit shorter, but this is due to perspective distortion in the reference itself. And here we're matching quite nicely. I mean, if we move this up a little bit, you can see that that claw there matches very nicely. Okay, so that's good enough for me. Now I can check this for size against our other bricks, but I really don't think we're going to have a problem. Let's just double check it before we continue on. So let's open up the finished bricks, and I've obviously got those hidden. Yeah, there's one. So there is our 2 brick with one set of geometry, our 2 brick with another set of geometry. This brick should match flawlessly. Let's just put this translate Z back to 0 and have a look if they are the same size. They are indeed identical sizes. This one is smooth, so it's probably appearing to be a bit bigger, a bit smaller, but they are in fact exactly the same size, which means that they will marry up very nicely with our other bricks. So, thanks for watching, and I'll see you in the next part. Hi, welcome back. So in this part we're going to look at making this bridging block, and this is actually a little more tricky than it would first appear. Now I'm going to use this part to talk about edge flow again, and why it's going to be important, especially when you're smoothing geometry. So we've seen so far that if you were to take, say, a poly cylinder like this, like we have for some of the knobs or some of the inside bits, and we're working on low division geometry here. So if we give it 8 and we smooth it, it's perfectly smooth. Now of course if we put smoothing control edges in here, that will be even smoother still, or it will hold the edge better so it doesn't collapse in on itself so much. And I'm just going to point out, as we've done before, that if you were to just introduce new lines to something like this, then you can immediately see on a smooth preview that it's bad. And I mean, most of the time that's quite obvious. So if we look at this guy, he's perfectly circular. If I cut another edge in here and another one in here, well, it's gone hideously wrong. So when we were cutting our bricks before, we've had to be careful not to flow the edges over the top knobs or under the bottom holes, because we get this kind of arrangement, which is no good at all. Now there are cases when it's much less obvious that your edges are actually going to affect what happens. So I took the liberty of modeling this block in a manner that seems to make logical sense. So let's have a look at it. So here's the block. I'm going to put it onto smooth, and it appears to be perfectly smooth. Nothing wrong with that, you might think. But let's put a material on it, just to make this a bit easier to see what the problem with something like this is. So I'm just going to go to assign new material here, and I'll just use a standard Maya blend material. We'll make it black because it makes it slightly easier to see in the viewport. And when I zoom into this thing now, you see these bands here. You can see one here, one here, one here. This is going to show up on your render. Now at surface blush, with this on a default material, you can't see any of that really. It looks absolutely fine. And the reason for this is we've got non-evenly spaced edges up here. As you can see, we've got these edges right now that are holding the smooth down here and around here. So again, even though it doesn't appear like we would have a problem, we've got that issue where we've got unevenly spaced edges on the top of a cylinder, or a curve in this case, and that's given us real problems. It's just this time it's very difficult to see those problems. So let's come in and model this. And I mean, I really wanted to point that out to you because we're going to go to some extra steps here to make sure that that doesn't happen, and without seeing that first, those extra steps can seem like a bit of a waste of time. But once you realize if you're going to be running uneven edges across the top of a curve like this, you're going to run into problems. There are ways to do it by spacing out the geometry on the top better, getting everything more exact, but generally speaking, you want to avoid it. So let's come in and get modeling on this thing. Now let's take a front view like this, and there are many ways to do this. We could use a NURBS curve again, or just a curve. We could use a box, go from a box modeling like we've done in the past, but this time I want to use a polygon plane just because it suits this kind of thing, and it's we haven't really covered starting from a poly plane yet. So I'm going to just rotate that plane up, and I'm going to get it to about the right size. Now I'm going to want to work on just half of this thing, of course. No need for us to come in and model both halves right now. So let's move the pivot, insert, snap it to here. This way, when I scale it, you see I'm scaling from the center. So that's, just a little bit easier than trying to scale, move it, scale, move it. Alright, now we'll look at the divisions on this thing. How many are we going to need horizontally and how many vertically? Well, at the moment we don't need any horizontally, because we're going to adjust the Let me just adjust this so it's a bit thinner. We're going to adjust here the width of this thing. So we're going to pull these vertex down until they perform a completely smooth curve. So we don't need any horizontally for now. We are going to need one or two, but we can put those in manually. So channel box, subdivisions, width. Now you'll see what's happened here. It's all gone completely bonkers because I've changed the pivot point on it. So, you know, when you're coming in and changing the subdivisions width and height, you're going to have issues if you've moved the pivot, if you've moved the vertex, you know. Luckily enough in this case we get away with it, so it's not too bad. But just something to be aware of, if we wanted, say, divisions in height, you know, because we've moved that pivot, that's not going to work for us. So my apologies there. Let's just get our divisions in because I don't trust that geometry after that. And let's get this down to divisions in width down to 1, so there's just no divisions across it basically. And let's once again just snap that pivot. So pivot, insert a line here somewhere along this edge. That'll do. Done. And this way when I scale, you know, I can scale from that edge. I've got the geometry I need. So I don't need it massive. Let's get it there, get it here. And doing it this way means that we have evenly spaced divisions across the top. Now I'm going to need to build the bottom box here, which is actually the same size as one of our one bricks, of course, this being Lego. So I'm going to cut one edge loop in. So multi-cut. Let's cut one edge loop in here. Done. And then I can actually take away, this reference has a bit of perspective distortion in it, so this is actually the bit we need. This is just perspective distortion, so let's take these ones away, delete, and there we go. That gives us a basis to form this box a bit later on. And now we need to come in and move the vertex down to this edge. So grabbing them all, move them down, and again grab them all but that one, move them down, all but that one, move them down, and just keep on going down the line. It really is this simple. Now you might have to do a bit of adjustment in the end, of course, you know, always a bit of adjustment to be done. Like this one is probably too low. There we go. And this, you know, is important. This adjustment phase here will determine how smooth your curve is and stuff, so take some time and get it right. You know, on a tutorial I tend to do this as quickly as possible. When I'm doing this in, well, in a production environment, then obviously I'm going to take a bit more time. It's just quite uninteresting to watch somebody, you know, exactly line up vertices, and I think you guys get the point of what we're doing here. So this time I'm going to take the bottom two, go down, take this one, go down. Now that's kind of done it for me. Let me just have a look here. As I say, I don't want to spend too long making it perfect, but I do want to get it so it is nice. There we go. This one seems a tad high, maybe. Tad low. I mean, the most important thing is we have even spacing along these lines, really. Now, again, we're going to run into an issue because there'll be a hole in the bottom of this. And you know, there'll be a hole in the bottom of the bridging section, so for our smoothing edges that's going to be a thing. So vertex, I'm actually going to curve this to give it a kind of gradual curve in as well, and that looks about fine. Okay, but now we're dealing with a single thickness plane, of course, and you can see on the bottom here there's a hole in the bottom of this, and you know, Lego is three-dimensional and this is two-dimensional at the moment, so if we just select the whole object, hit extrude and extrude this. Now I'm going to go for divisions 1, of course, to keep the geometry nice and simple, and I'm not going to be too concerned about how fat it is right now because we can line that up here on the reference quite easily. Vertex, I'm going to pull this out like so, and then because I want my model completely in half, at the moment this has no central symmetry line, which is, you know, It's not always a problem, but for me I want a central symmetry line. So rather than trying to get that exactly in half and doing some measurements, much easier way to make sure that you're perfectly symmetrical is just stick a edge loop down it, chop it in half, and then mirror it across, and that way you know that you're always going to be perfectly symmetrical. So mesh, mirror, and let's find the right axis here. So in this case probably Z and negative, there we go. No, what has happened here? My pivot point's in the wrong place. Silly mistake to make. So yeah, your pivot point is here. So you're never going to mirror across in this direction, of course. Hit insert, align your pivot point with the edge you want to mirror along. Insert again to come off that pivot alignment, and just mesh mirror. So direction looks to be wrong. Axis is wrong. Z. Okay. So we still have an issue with that pivot point. I'm not quite sure why. I did move it, but these things are certainly sent to try us. Okay, so we do not have a problem with that. So this should be mirroring positive x. I'm not quite sure why that didn't work last time. Let me just come in here and mesh mirror, and that should be positive x. But it isn't. So, okay, yeah, I see what's gone on here. Just a second. So, yeah, there we go. So just a case of getting the right axis and direction. Now, let's make sure we are on reference. Now we are exactly halved, and we can see here that our leading edge for the bottom guy stops here. So let's select that vertex just so I can see it in the other viewport, and make sure that that is indeed where our leading edge comes down, and it is. Alright, I can pretty much get rid of the reference for a second because it's getting in my way. And now what I need to do is cut in the holes in the center of this thing. So of course we would need to edge loop down here and edge loop down here, and then edge loop here and here for smoothing. Now let me just, before we do this, bring this reference back so I can get the width of this thing. So modeling toolkit, multi-cut, you can see the edges there and there, and what we have here is the perfect edges for this one. So in order to make that a box, we need to select all of these edges, all of these faces, sorry, not edges, and let's make sure we've selected the right faces. We've got our camera on the top, we need it on the bottom. So panels, orthographic, bottom one, let's come in, and now our reference plane is going to be blocking the view, so we'll move it up. And now we can come in and select the correct faces. We could have done this on the perspective view as well. There we go. Now make sure we got the right ones. We do, and then we're going to want to extrude these downwards till they meet the bottom of the model. So again, we can do this on maybe the side view here. So let's extrude these downwards. So extrude them down until they meet the bottom of the model. There we are. Divisions 1, of course, for us. Okay, and let's have a look. So we've got a definite hole in the bottom now, should be fine, and let's smooth this. Okay, you can see it goes a bit like blancmange. So now we run into the issue of we need another hole in here. Now for this, because I'm going to make the double wide bridge first, I'm going to come in and I'm just going to select all of these faces, I should think. Yep. And I'm going to want to extrude them inwards. Now before I do that, I'm going to get rid of these two faces on the front. Because we are mirroring this across, we do not need these faces on the front anyway, and they're going to run into some issues with our extrusion. So let's extrude all these inwards. Okay, divisions 1, of course. Again, keeping it simple, and get rid of those front faces for the mirror operation. So now we've got about the same size hole there as we have there. Okay, let me just nix that reference. so I can see what I'm doing. Alright, now let's look at this on a smooth view. Okay, so we're not getting banding across the top, which is good, but also we're looking rather blancmange-like, which is no good at all. Now, we already know that we are going to run into serious issues if we just do this. And this is why I built this model first, because it seems like the logical thing. If you want to hold this smoothing edge, then you're going to need to cut an edge loop around here. But we know, because of this, we're going to run into issues. So let's smooth the bits that we can do easily. So this is going to be rather simple. And this one here, to hold this edge, is going to be rather simple. This is going to go across the top lengthwise, which doesn't matter for our smoothing. So this one is going to be nice and easy. And this one is going to be nice and easy. Alright, so we've got some smoothing in here. We need another one here. And another one here. And finally we need these ones, of course. Okay. There we go. Done. Now I could work on just half of this, which I think I will. So to avoid us doing, things more than once, and we've got a perfect center line now, so let's use it. Alright, so just make sure I didn't get rid of any faces I might need. So, as far as smoothing goes, we are pretty good. However, you see we've got problems at the back here, where it goes like blancmange, and we've got problems here, of course. Again, not good. Now, we need to hold the edge around here. Done. And we'll need to hold the edge around the bottom, of course. Done. And we need to hold the edge here, which we can't do without cutting across the top and getting banding. But we'll look at that in a second. For right now, I'm doing the ones that I can do easily. So one around here. Done. That one will have to be altered by hand a little bit. And we'll also need one around here. Done. Now, let's have a look. Okay, much less like blancmange, but still definite pinching in this corner. And it's not quite holding. Yeah, and look at this. Look, this is bad. Bad, bad, bad. Now, the reason for that should be fairly obvious. That reason is that there's no smoothing control here. There's no smoothing control here. There's no smoothing control here. So yeah, this leads us with a bit of an issue, which we'll sort out presently. Right now, I want to sort these edges out. They're all coming a bit too close together for me. So I'm going to take this edge. I'm just going to redirect this edge flow a little bit, so the whole thing mimics the kind of bridge we've got going on here. Now these lines are on a flat surface, so realistically this wouldn't be much of a problem if you left them all jammed together. It could cause problems down the line, it can cause problems with animation, but again, this is not really going to ever deform because it's solid plastic. So it can cause problems with dynamic simulations and things like that though, so it's better just to take the 2 seconds, and I haven't actually done that very well, but I think you get the point, so I'm not going to spend a great deal of time on it. Now, we need a smoothing control edge along the top. There's no way around it. We need it. We have to do it. So, let's put one in. So I'm going to put one in here. Bang. Which will stop the pinching and help us keep this edge, of course. So this should look fine right now. And I'm just going to go on to object mode so we can see that. And indeed, it does look a bit bad because we'd also need a smoothing control edge here. But let's deal with this one first. So now we've got a problem. Now we have unevenly spaced lines going across the top in this direction, which is going to give us that banding we saw at the start. So let's get rid of them. Edge. So, Shift, right click, delete edge. Now, we can't leave this this is now a huge n-gon here, so it's not good at all. So we're going to cut in with the multi-cut because we need to retopologize now. And this is a flat surface. It's never going to deform. This is the part that's being smoothed. This is never going to deform. So although we don't want to leave an n-gon on our triangle on it, we don't have to worry too much about being uber neat. So I'm going to come over here like so, and this cleans up that n-gon there. So this is now 4 sides, these are all 4 sides, these are all 4 sides, and we just have an n-gon here. So we can simply join from here to here, and this is now 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and we've done it without going over the top. So let's have a look. 3, and no banding across the top. So, you know, we retopologize here, put an extra edge in. Now again, we're going to have to do it here, and this can get seriously complicated. When you keep putting edges in like this and you're always having to find routes around, this can get genuinely tricky. If you're just starting out in Maya especially, but even if you've been using Maya for years, this is still the equivalent of a jigsaw puzzle here. So it's still one of those things where, you know, even very experienced people come in and need to look at it, spend some time, you know, getting it right. So for instance, can we cut across here without causing an n-gon? Yes, we can. So, you know, if you're new to all this and you're finding this very tricky with where to put these edges, you know, that's just something you live with in any 3D application. There's better ways to do it than others, of course. There's ways that are right for the situation. There's ways that are just quick. But there is no real, this is the way you do it. I'd love to say, you know, in every circumstance you just do it like this. But it's not always the case. It depends what you're handing the work off for. If it's just going to be rendered and you don't need to worry about animation, deformations, it's a background thing, then you can care less about topology. Obviously you still don't want to be leaving large n-gons on your model and things like this, but you know, not everything is shot from an extreme close-up. So without putting these edges in, there is an argument to be made. If this was a background Lego piece and would never get closer to this than the camera, then you know you can do away without some smoothing edges sometimes. It really is dependent on the situation, what you're using the piece for. Is it set dressing? Is it a hero object? You know, and you can see here that now I didn't, when these ran around, I didn't change them along the back. So let's come in. This has nothing to do with our retopologizing up there. This was just me not doing this before. So again, you know, you got to pay close attention to the edges wherever they may be. It really is quite important where your edges are flowing and how they're flowing and whatnot. And this is, you know, it happens a lot when you start in a 3D application, especially one like Maya that is so sensitive to topology. I mean, it's done for a reason. It's done because good topology makes good models, which make for good production pipelines. You know, it makes it easier all the way down the line, from the UV guy, the texturing guy, to the dynamics guy, the creature effects department, and so on and so forth. So when you have perhaps used other applications, Lightwave, namely one, the focus is not so much on topology, so it can seem easier to use when you first start using it. You know, keeping your topology good is the reason why your models will look better. Now I've just noticed we need a smoothing edge in here, because you always want to be coming to the small squares around the smoothing edges. And let's smooth this and see what it looks like. Now you want to make sure that your retopologizing is not having any effect on your smoothed edge. So you don't want to get this kind of geometry too close to a smoothed edge. You can see it's pulled it a little bit. So there are a couple of ways to combat this. You can put another edge in here. You'll see also that retopologizing this has changed the direction of our edge flow around the model as well. So that's also something to be aware of. I believe in one of the earlier parts we looked at the retopology of one of these Lego bricks specifically to change the edge flow, so we had edges running in a different direction. Well, sometimes you can end up with a situation like this where that's not what you wanted. But again, it is, 6 of one, half a dozen of the other as to what is correct for the model at the time. So, let's just put the rest of the smoothing edges on this. So we know as well that we're going to need one here. In fact, there's quite a lot of these. I mean, this will get quite, I wouldn't say tedious, but quite tricky to work out all the time. So again, we can't have these edges running across the top. And as I say, it does become a little like a jigsaw puzzle. If you're very into your puzzles, then you might find this kind of thing very satisfying. A lot of us do. So multi-cut. Now this time I could take this way, under here, and that's a straight edge, but again, as I said, a little puzzly here. Now, is it better to run it across this way? Yeah, I think for this edge I'm going to run it across this way. It doesn't cause us any end-on problems, and I can just come up here for this one, like so, and object mode, and 3 to smooth. Now, I'm really not liking what this is doing to my smoothed edge. I mean, you probably can't see it. I'm probably nitpicking. But, in a situation like this, we can always come in and cut another smoothed edge. So if we were to just take this whole edge here, keep selecting it, and just move it down ever so slightly. I'm going to use the slide on edge tool for this, so shift, slide edge tool, and let's get that so it's like so. There we go. Done. Okay, and because this was getting too close to the smoothing edge, there's these kind of poles. You'll see here this is a pole. It will pull in your geometry. It's not bad if you're on a flat surface like this one that's not going to deform. In the crease of a character's elbow or on the corner of a mouth or something like this could cause issues. But for geometry like this, it's always going to be flat. You don't really need to worry about it too much. And now I can cut in a different smoothing edge around here, like so. And this smoothing edge is not affected by the poles here. So, better, in a word. Not perfect. I would go in and neaten this up. But, for this, we're getting no banding across the top. We get perfectly smooth edges. We're smooth around here now. This is nice. For what we want it for. And Maya is all about that, the purpose that you're using it for. So it's not always about getting perfect squares. It's not always about getting, perfectly even face distribution, although that certainly helps. Again, it comes down to circumstance. It really does. So let's cut in the last smoothing control edges we need. So in this case, we're going to multi-cut across here. And edge. Now you see, as we add more geometry to this, the more complicated it gets. So it's a choice now of where I terminate this edge, and I think I will terminate it there. Again, this is not something I plan for at the moment. I haven't spent a lot of time analyzing this piece, so there could be a better way to do this. Let's go up there to start with, and then let's just go around the corner. Yeah, there could be a better way to do it. This is a way that works. And again, as it's a bit of a puzzler, you can always come back and look at your topology and go, not happy with this. This is a quad, but it's quite a long edge, and you can see how that really pulls in this line here. However, as it's on a flat surface, it's not going to make that much of a difference. So, again, it really depends on what you need. So let's multi-cut here, and once again we know that, yeah, we can terminate the edge, let's say here. So let's delete that edge, and let's terminate it here. Delete edge, and I'm shift and right clicking to do that. So let's come up. Okay, this time we'll place it over here, and we'll go down. Whoops! So enter to finish the tool. Okay, that does that one. Now this one's really not very good. This is a very, very long triangular type of face. So I'm not really happy with the placement of that. Let's come in here, take this vertex. Let's try and, you know, make this a little bit nicer. Unfortunately, sometimes it becomes quite difficult because of the position of the edges. What I probably should have done with this one, in fact, let's do it. Let's delete this edge and delete this one. So I'm basically taking out what I'd done, and I'm going to cut it from this face instead. So multi-cut, let's go right across the top there, and make sure that's in the right place for smoothing, because that would be a bit tragic if it wasn't. So this time I'm going to take the edge from a different location, and again that's something you're going to have to do quite a bit. You know, it's not always obvious to see where the topology should go, and it's not always possible to get something that's you know, that's exactly how you want it. It's just not. Without major retopology of the whole model, which a lot of time would be a little bit excessive. So let's multi-cut up to, say, here, and then go this way, and then run it round. And that doesn't leave me with quite so long a face, but it does leave me with quite narrow spacing here. So yeah, there you go. But it's a little better, I think. And just double check for n-gons. We don't have any. We don't have any uneven divisions running across the surface here. So that's brought that all the way down there, and it's not affecting this smoothing edge. It's not affecting this smoothing edge. It doesn't look like the neatest thing in the world, but it really doesn't need to. Okay, so I believe we have one more to do here. Let's turn that off, smoothing. And we do. We've got one here, and finally we need one here at the back, of course. So multi-cut in there, and again we've gone off the top. Can't do it. So delete that, and let's pick a place to terminate this edge. Okay, so I'm thinking possibly here, where there's already too many rows running down here. So delete edge here, and let's just terminate it here. It's 2 away from the smoothing edge, so it's not going to matter that much. And I'm going to come up, I'm going to cut here, and here, here, and here. Done. And of course I've got a whacking great n-gon across this thing now, so I'm going to have to go up to this corner, which I don't really like because it gives me, you know, that, which is not wonderful. No, that can't happen. That was not a good edge to put in. So yeah, because if we put it up here, it's really going to affect yeah, in fact, with this one, let me undo the deletion of the edge there. With this one, we actually need it to go all the way up. Now, with these, they're holding smoothing controls down the bottom of the model. So, you know, there's no need for the smoothing on the top. But for this one, we actually need it to go across. Okay, because it's holding this edge here. So there is little choice here but to run one across the top. Now let me straighten this up because I don't like it all bent out like that. There we go, object mode 1. Alright, but let's see if this causes any banding. Now it might not, because part of the reason for the banding, as well as having uneven loops across the top, is having a loop in the middle and another loop really close together. So let's apply that same black blin that we had before, and you can see, get no banding here. Okay, this is because we just have one loop going across. We don't have loop, 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 all in, close proximity to each other. So for that last one, we can actually get away with just having the topology like so. Now I would come in, now we've put all this extra stuff in, and I would move these about and try and get them a bit more evenly spaced, Now, you're never going to get it perfect, and nor do you need to. Again, you want to pay close attention to geometry that is near smoothing edges, of course, because if that goes around a pole and pulls out your geo, then you're going to have an issue. Like we were running into up here before we put the other smoothing edge in. When this pulls this into a pole, you can see it sort of makes a humpback bridge with this, and if that's a smoothing edge, then that's a problem. So I'm quite liking this. What have we got going on down here? Yeah, we actually need one more smoothing edge. So now we've changed the edge flow around here, we can actually just do this, because this is going to flow around this other one we cut, and then around the front of the model. So in this case, the edge flow works to our advantage. Okay, so that was nice and easy. Now this smoothing edge here, I see it's a little bit far out, so hit one. Actually, no, it's not. It's perfect. Fine. So, this last edge we did reflowed up here perfectly, and if we wanted to put other edges in here, they're all now going to reflow from here where we change the direction of the edge flow. Same here, if I need another one, this will now flow backwards. So again, changing the topology for edge flow, as we've done already on our Lego brick, makes sense on this, so it allows us to cut that nice one in. Let's have a look around this. I mean, yeah, look, the smoothing on this is great. We're getting no pinching, we're getting no banding across the top. Let's mirror this thing and make a whole bridge just to check it out. So our pivot point will need to move, of course, and in fact, no, in this case it's in the right place. So let's do a mesh mirror, okay, and negative, and in this case Y. There we go. So let's do it this way first. Okay, no, that's behaving exactly as I want it to behave. So let's mirror it across and make sure we're getting no banding. There is no reason we should be, but okay. So let's put that black blin on it, and you see that the top is perfect. So that's going to look superb when you render it, as opposed to the one I knocked up earlier where we didn't redo the flow of these edges and you got that banding right across the top there, which you can see now we do not have. So, in certain circumstances, if you're modeling from a cylinder, and you put an extra edge loop across the top of it, you can immediately see in the smooth view that what you've got is wrong. It just doesn't work because the cylinder actually changes shape. Now, in more subtle cases like this one, where you've got a much bigger curve, so you go, okay, that'll be fine, I'll just put a loop here, and then you smooth it. Well, if you've got one edge like so and you put two loops either side of it, what you've done is put smoothing control edges in it, so that's going to create a band across the top of your model, and that's just not going to work. So you need to retopologize once again for edge flow. Now you can look at spacing these out a bit more evenly. For me, they're away from the control edges, so it's not such a huge issue. Now there is one other thing we need to do before I quit this part, and I know this has been a rather long part, but we do need to, I'm just going to delete the history on this guy, so edit, delete by type, history, and we do need to make a single block version of this, which actually has a riser like this one going across the middle. So let's just cut this back in half after we duplicate it. So there we go. So again, and I apologize, this part is a bit long, but this is really the difference between what makes a good looking model in Maya and a well functional model in Maya and what doesn't. And it's very difficult to grasp that when you first start. At least it was for me, and I know it is for a lot of other people. So, you know, just be aware that edge flow and topology make a huge difference, as we've seen before in the tutorial, and I know I keep banging on about it, but it really does make a difference. Now, we need to come in and make here a lip. So best way to do this, okay, first let's turn off the smooth view because that never helps, and we need to move these faces down. So there's a couple of ways to do this, as always in Maya. I'm just gonna do it quite simply. I'm gonna delete this here, then I shall probably extract these faces and just move them down. In fact, I could extrude them down, but that could cause issues. So I'm going to use mesh extract, edit mesh extract. There we go. Just click away from it, and this will give me these faces extracted. So if I go into object mode, you can see here I've got a separate object. I'm going to modify, center the pivot on them, move them down here. So basically I've just moved them from up there to down here. Now I need to combine this into one object, so I'm going to go into a view where I can see this properly. So let's have a look here. Okay, that's our finished large bridge, so I'm going to hide that. Control H, and let's see if we can make sure this thing's lined up. So just get it on the same line. There we go, perfect. And now we're going to do a mesh combine. Okay, but that won't have done it, because you'll see if I select the vertex here, it's separated. So you can either use the target weld, or you can grab them both. Make sure you just have those two vertex, or things are going to go very wrong very quickly. And then we need to mesh merge. There we go, done. And you don't need a very big distance threshold because they're basically on top of each other. We'll get a little bigger than that just to make sure they're merged. Take this one, hit G to repeat the last command. So I'm going to hit W just to make sure my pivot is here, because that means I haven't accidentally selected anything down here. G to merge. Again, give it a slightly larger threshold just to make sure we've got those merged. Now you can check that they are merged by hitting vertex, moving it, and if the whole lot moves together, it's merged. So that's given us the start of that. Now we need to get a bridge from this edge to this edge, and that's going to cause us some problems with these smoothing edges, but we'll fix that afterwards. So bridge, there we go, and we need to go this one to this one, bridge. Okay, and you'll see here that that leaves us an edge flowing to absolutely nowhere. So don't leave edges that don't go anywhere. So the multi-cut tool here is giving us a problem because it doesn't like to join this and this because of the topology. So let's get it close here. We'll straighten it up later. There we go, close enough, and bring it out to here. Done. And then we'll need to what have you done? Right, let's just put the loop in there using control, put the loop in there, and you'll see they aren't actually joined together. Let's go to target weld, let's go to vertices so we can see them, and target weld these together. There we go. So now we should smooth, shouldn't be any problems. Let's come off the target weld tool, and there isn't. Okay, so you should always be aware that when you're doing an operation like this, whether it's an extrusion downwards or inwards or whatnot, that you can run into significant problems if those edges aren't merged properly. And you'll see we need a smoothing control edge here now, of course. Now we've put this lip in. Okay, but that should be a nice easy one to do. So let's just throw in our smoothing control edge here. Now run the multi-cut tool with control held down. Make sure you're getting an edge loop all the way across the thing. You know, this way you'll know that you don't have unmerged vertices, broken geometry, non-manifold geometry, whatever you might have. So let's put our little lip in, and we need one more smoothing control edge here. Done. And this one might be absolutely fine to run across the top, but you know, because it's not three edges together. But let's just do this as an exercise. So it is this one, yes. In fact, let's see if that does need taking out. Let's just apply our material, blend one. Yeah, you can see, banded. So not good. And still banded. Still not good. Alright, let's get rid of it. Sometimes you get away with it. You know, I wouldn't recommend it unless it's, you know, something you can't change. Sometimes you simply can't change it. It's not possible without, you know, creating an entirely new object, rethinking how you start the design. And sometimes with an edge like this that's right at the bottom end, it's going to control the smoothing across here. That's fine. It's at a termination point. It's not in the middle. Doesn't have three edges close together, but also it has to go all the way up here to maintain this edge. So in that case, you are kind of stuck with it. Now this one's not too bad because it's right on the edge here. So let's come up, let's come out, and let's just join these together to get rid of that end-on, and we're done. Okay, so let's smooth this. Done. Q. Done. Okay, so you know, from the simple start of the bridge that was just edge loop, edge loop, edge loop, edge loop up, we've come to a much more complicated piece of geometry here, but it was necessary. You know, let's mirror this one across. So we have, because we're going to need to put some faces in here as well. On this one, because this is only half a block. So for our bridges, we have two separate bridges. We have a full block. Let me just change that to Lambert. So we have a full block, but we also have a half block, because Lego do these in two sizes. So they do like a full one and one that's cut in half. Hence the reason this one has this lip here. So let's mirror this one. Let's check its pivot point. It's in the wrong place. Insert, let's move it to the right place. Insert again and mesh mirror. Now before we do that, actually, let's go ahead and add the in fact, we've got more going this way than we have going this way. So in this case, it's one of those fairly rare exceptions when it might be easier just to work on the whole thing. So there it is, mirrored across, object, and now we can bridge. So let us bridge here. You see here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, it's pretty much horses for courses, so we could have done this without bridging, but without mirroring. But either way, it's not going to be that much faster. So let's just take this edge. Let's see, which way do we want to bridge? We can bridge top to bottom or left to right, you see. So in this case, I don't think it's going to make that much difference. Bridge. And in fact, let's see if we can do this all in one operation. So I'm just shift and double clicking on that edge. I want to make sure we've got no other ones. Bridge, yeah, we can do it all in one operation. But Now we've got the issue again, the same one we had inside, with no edge loops running around the front. So we're going to have to multi-cut in on the location where these loops are. Try and be as accurate as possible. Again, for tutorial purposes, I'm not going to spend too much time here. But if we get them all pretty much on top of each other, then we can just merge the whole thing in one go, which is kind of nice. So they seem to be pretty accurate. Let's make sure I haven't forgotten any. No, all, yeah. Okay, so now select the whole mesh, edit mesh, merge. Now with a fairly low threshold, too low a threshold and it won't merge them together. See, this one is not merged. So if we go up to 0.01, you'll see it is now merged, and you want to make sure that that threshold hasn't merged together anything you didn't want it to. Because if you put that merge threshold at say 1, it's going to start merging vertices all over the place. In fact, that was so high that it can't even do it. But look, 0.05, so yeah, be aware that you don't want that too high, especially where you've got geometry that's quite close together, vertex points that are quite close together. You could end up merging them by accident, so you know, be aware. But all of these are now merged, I should think. So let's come in, click off that, hit 3 to smooth, and we are pretty smooth here. Now we need one final control edge in, which would be around here, because oh, let me do that again. So I'm just going to undo that. I accidentally put an edge loop around here, if you're wondering why I undid. There we go. And 3, done. Now that one has to go across the top, because it's holding this edge here, and it's holding this edge all along the way. It's actually holding this edge here, so it needs to be along the top, the same way this one needs to be along the bottom. Now we can apply our black material to this to check for banding across the top, but I think you'll find we simply don't have any. Okay, so thank you for watching this part. Apologies that it was a bit long. We seem to have a little smoothing issue here, maybe. Why is that happening? Oh yes, because we need another smoothing control edge here. So and this one again will need to be taken out. So just as I was saying, apologies for this part being so long, it gets a little bit longer, but again, I'm sure you guys would rather see this done correctly. So let's pick a face where we can go across, and again, I'm not going to bother to cut this thing in half just now. Realistically, this is pretty simple stuff, so delete edge, and again, let's do what we've done many times before. Let's move this up to here. Let's pull this one. Where would this one go now? Here. Enter, and let's just run it all the way around as neatly as we can. Okay, so that's going to come up to sort of here, terminate here, done, and cut here to here. Done. Okay, and that is pretty close to our smoothing edge here, but I don't think it makes that much of a difference. Let's look at it with this blin on, quite nice to see. No, perfect, no banding. Yeah, topology could be a bit more organized, but it's all on a flat surface, so realistically, not going to make that much difference. We don't have the pinch down here anymore. So, you know, I'm happy with that. Right, and again, as I said, apologies this went on a bit long, but I think it's kind of necessary to do a part like this, just to simply show you that everything on the surface of it is not always as simple as it seems. So that's it from me. I'll be back in the next part, and thank you very much for watching. So this is the piece we're going to tackle now. As you can see, it's another complicated brick, or not too complicated in this part, but it's got these two round circular things on either end and a bar that runs across it. Now I chose to do this brick because in the previous part we took a bunch of different primitives and stuck them together. We created some things out of a curve, And we stuck that together with some other primitive objects, and then stuck that together with the main brick and made sure the topology and edge flow all worked, and we got, for our trouble, a very nice brick. Well, we're going to do the same here, but with a slightly different technique. We're going to use a polygon this time, and instead of adding two polygons here, so one tube and another tube, we're actually going to extrude everything we need out of a single piece of geometry. So it's a slightly different way to do it. And I'm going to bring in a cylinder to start, hit J to lock the rotations, and flip this so it's front facing. Then I'm going to move it out approximately to the reference and get it there. Now obviously we'll do this in the side view. One of the things I want to see before I go into the channel box and decide to give this more or less geometry is how well the edges would match up with our box. So let's get this to about the appropriate size. And my reference was a white Lego brick on a white background, which actually turned out not to be very good. So the black lines you can see here, and indeed the red lines, are just added in Photoshop to give us an easier view of the reference, which is done quite a bit. You're not always going to get the perfect contrast on your reference, so quite often you'll go in and overdraw the lines in something like Photoshop just to make it a bit easier on yourself. Now what we're looking for here is to be able to create this box here that goes through the cylinder. And you see with our standard 20 divisions, what we've got is an edge we could extrude out here and an edge we could extrude out here. So this fits perfectly. We could possibly do it with slightly less divisions. Yes, we can do it with 10, so that makes more sense to do it with 10. But if we change it to 8, which is what we've been using so far, you see these are in the wrong place, and no matter how I rotate them, I'm going to have to end up moving one, which will spoil the overall smoothing of our circle here. So let's go as low as we can. There's no point using extra geometry that you don't need. So now we've got that in place on the side view, let's get it in place on the top view. And there we go. I just imported these image planes exactly as we've done before, by the way, so I didn't see any point to take you through that again. I think we've pulled enough image planes in and out and about now that you would know how. Okay, so we have this. Let's check the side view, and we're perfect to extrude. An extrusion along here, an extrusion along here. So we need to cut this center face portion, this center bar in now. And that's quite simple too. We're going to do an extrusion on that. So this middle line is approximately where that center extrusion needs to come from. So let's come in with our multi-cut tool, modeling tools, multi-cut, and let's click and drag this out until we get 25%, 30%. I'm going to go a tad smaller, so I'm going to go to 30. I can always adjust it later. It's very simple to adjust. So let's just go to 30% all the way around. And that cuts us in here a nice edge loop. Okay, close the circle. Done. We'll look at these triangles later. We might actually just leave them in here. They're not going to be much harm. As you've seen, we've retopologized this sort of thing before. So again, I want to not take up too much of your time in this part. Now, if we click the whole thing to get the edge loop, we can just press Shift and use the Slide on Edge tool. And middle mouse button and drag, and as you can see we can slide backwards and forwards to wherever we want this edge to be. Now by default I believe the slide on edge tool comes with snapping, so if you just take it off you can turn the snapping on or the snapping off here. I have mine turned off as I'm not using it at the moment. Okay, so that's given us an object that looks something like this. So now to build this shape here with the square coming out and connecting to the Lego brick along this divide, all we need to do is delete the faces here. So let's get rid of these faces, and I'm going to turn the reference off for a second. So channel box, flip the reference off, and this face, this face. So just three faces we need to get rid of, really. Delete. And then we're going to look at the topology of the block to see how it would join together. Now luckily enough for us, we have an edge here we can connect to, top and bottom, and we don't have quite enough edges to connect this one. This one will connect to the bottom quite nicely. Unfortunately this one won't, so we'd need another edge loop in here. So let's combine these objects, mesh combine, see if it works on the first time. It does. Good. Okay. And we could have gone in the top view. Actually, let's separate that. Before we combine those, I just want to check the alignment of this. It looks slightly off to me. And it is slightly off. So to make our lives easier, I'm going to center the pivot point on this and just move it this way a bit. Now the reason I'll center the pivot point is simply because it gets a bit awkward with a pivot over here. So let's make it central to the object. So modify center pivot. And let's come in and move this across until it's online. Now we can of course straighten up these vertex later with the scale trick, but the closer you are to start with, the easier it's going to be. Okay. So once again, select both, mesh, combine. There we go. And let's just combine this thing. So we'll select edge, we'll do an edge extrusion. And I know I'm going to need to delete these faces in here. So let's see. Okay. Actually, if we look what we've got here, we've actually got two edges and only one here. But we're going to need a smoothing edge in this to hold its final shape anyway. So let's do that before we start. And things like this, making sure that the edges are the same on both objects you're trying to connect together before you start connecting them together and getting in a mess, is a very quick way to do this. So let's put a smoothing edge in here and a smoothing edge in here, like so. And now we have 1, 2 edges, 1, 2 edges. We have only one edge, so we're going to need to put another edge in there. Now because we have, let's see, let's get it round this one maybe. Yeah, because we didn't want it to go over the top. So here it would go over the top, here it wouldn't. And we can always come in and adjust these edges. Let's check the top view. So okay, these are going to marry up wonderfully. These, not so much. So let's change them a bit. Let's go into vertex mode and select all 4 of these and just drag them this way a bit. We're going to try and keep them straight, well, you know, straight-ish. And now we've got a much better connection here, and the topology there doesn't look too bad. Okay. So now we can do this whole thing as opposed to, you know, lots of different primitive objects. We can do it with one object and some extrusions. So let's go in and delete the faces. Otherwise we will get that issue with having faces on the inside of the model, which we do not want inside faces. All sorts of problems will occur. Now, edge. And I'm just going to, I could either do an edge extrusion now, so click this little point here to center it and extrude it out, and then join that up, or in this case I can actually do once again a bridge. So let's click off the extrude tool. I'm just going to undo, there we go, and click this edge and bridge. So we could have done the extrusion first. Sometimes you'll need to do the extrusion first. But sometimes you get this very nice situation we're in here where this becomes quite simple to join up. So I'm going to get this one and this one up here, and this might be an issue. No, I think that should be alright. We'll take a look at the topology when we finish the bridging. So this one and this one, bridge. There we go. This one and this one, bridge. Okay, so it's not the best shape. I believe we're all still quads, and we can come in and sort of even these up in a little while. But actually, it's not that bad. Bridge, and bridge. And finally, we've got the ones along the bottom to do. So bridge, and we must have missed something here. Yes, we have. We've missed this one. Bridge, there we go. 1, 2, 3, 4. We're still quads. And I'll turn the grid off, it'll make it easier to see. So just flip up here, turn the grid off. Bridge, and bridge. There we go. So now we've got this all nice and neat and tidy. We've got the smoothing edges going along this way. We've got the smoothing edges going along the bottom and along these sides here, although these smoothing edges are going to be a bit out of whack. So let's come in and just take our vertex selection, click and drag, make sure you've got both. That's easier to do in the side view, by the way, and scale it down like so. So we get a nice straight smoothing edge. Now this smoothing edge up here is going to be an issue, so we're just going to pull it up until it's also nice and straight and smooth. Okay, and I forgot to do both of those at the same time, so we'll just do them separately. Now here we don't have a triangle because we have 1, 2, 3, 4. It's not particularly good topology. We can look at it in a later part, but to be honest, for this it should do just fine. Now the next thing we need to do is take these faces here and extrude them out to the center line of this block. Extrude, click here, go here. We have too many divisions, so middle mouse drag, done. Let's do this on the top view so we get that out to exactly the right place. Okay, that should be right, I should think. Done. And let's see what this looks like smoothed. So these sides are looking okay. This is looking a bit like a dog's breakfast, but we need to join this with the other half, so we'll mirror this in a second. We could do with another edge loop going around here to hold the smoothing, and another one here to hold the smoothing. And on this part where we're all actually triangles, we need to cut this in manually, but that's okay. So let's go 80, or we can do 85%. Okay, done. So that's the smoothing edge there, and that's a little big, to be honest. If we look at the smoothing edge on this one, they're quite close together. So again, not an issue. Go to edge selection and slide on edge tool. So you want to hit shift and the right mouse button, slide on edge, or slide edge tool. There we go. So now it's about the same as the one on the other side, because we're always looking for, you know, a fair degree of consistency. We don't have to be spot on all the time. And that's looking much better. Let's check it against the reference. So yeah, the thing is that our reference is much sharper around this point. So if we just take some vertex here and push them, oops, I accidentally clicked off. So that's not gonna work. Okay, we've gone slightly off the reference here. Let me see this from the side view, but not so much. I think a lot of that is because we're getting too much smoothing here. In fact, I'm sure it is. I mean, the problem is that this is not a sharp edge. It should be a sharp edge. We're slightly off the reference in terms of size, but again, if I wanted to, I could just take this whole thing and scale it slightly. But we're not that far off. I mean, if we look in the unsmooth view, you know, we are pretty close here, certainly close enough. Yeah, and we are perfect here to the reference. I think it's just because there's no extra smoothing edge here, it gets that sort of big kink in it. So I didn't like that. Let's reinforce an edge here to stop that happening. And if we reinforce this edge here and this edge here, we should get a much sharper break. We do. Okay, I still would like that to be a bit sharper, but I don't think I want to add the extra geometry for it. I don't think it's worth it in this case. Now it's sharp, and we only had to add one extra edge loop. So okay, yeah, I think that will be fine. Now our topology here is it's not brilliant, to be frank. And I might have a look at that in between the parts. Now, this topology, because we know we're not reusing this brick, it's not going to deform, it's all in quads, except for the back triangles here, which if we take out every other one, should make a quad anyway, so that's not really much of an issue. In this case scenario, for a one-off brick usage like this, I probably wouldn't waste too much time retopologizing the whole thing. I'm going to have a look at that in between the parts, and I'll come back to you with a different topology, just for your own personal education on this, so you can see a different topology for it. But sometimes, if you're all quadded and your model is working on smooth and you don't intend to deform it, i.e. bend it around like a rubber band, then sometimes you don't need to get everything quite so equidistant. I mean, if we look at this on the smooth view, it actually smooths out very nicely. There's no sort of artifacting on it, and everything looks perfect. It's all quads, so you got to pick your battles sometimes. Now, in order to make this the whole piece, I'm going to select faces and I'm going to get rid of all of these. Now I'm going to hide the reference just so I can check underneath here. Okay, and make sure we get half for the bottom as well, of course. Done. And now we can just mirror this thing across so we don't have to model the other half of this. So let's just go to see what axis we're in. We're in X across this way at the moment, so that would be positive X. So mesh. Before we mirror, of course, we'd need to sort out the pivot point. So let's hit W to move and insert to move the pivot, and just bang it here. So click on that vertex to align it, insert again to come off the align tool, spacebar, mesh, mirror. Okay, and the settings happen to be positive X. So that's absolutely fine. That seems to have mirrored together quite nicely. Yeah, not seeing any errors in there. So let's just hit object mode and smooth this and see if we've got our brick. We do indeed have our brick. Now, our grabbing arm should be able to grab onto this bar, because this bar might be a little bit too thick. It's very difficult to see from the reference shots we've got. I actually have the piece in front of me, and this is kind of how thick it looks, maybe a tad thinner. So let's bring in our finished bricks. And let's get our grabby arm, because this is the piece that the claw thing grabs onto, and let's just check this for consistency. Okay, that looks pretty good to me. That's going to grab onto the arm like that. Let's check it. So let's pull it down. No, I'm pretty happy with that. That actually turned out to be the right size. And again, you can't always get perfect sizes off reference. You're going to have some image distortion. You're going to have, possible scaling issues where you rushed it a bit in Photoshop. There are ways and means, of course, to shoot very precise reference with good photography equipment and the right measuring tools down on the table and whatnot. But for something like Lego, if your bricks all fit together and they all look identical to Lego, then that's the battle right there. If it's within a sort of, I don't know, maybe a half a millimeter, what would that be in inches, 1/16 of an inch, something like that, 1/32 of an inch. Sorry, I'm not very good with inches. Then you're absolutely fine. So if we plonk this one on here, duplicate this brick, and can we get two on the same bar? Yep. So we're maybe a little bit too fat here, but again, I'm going to do a part at the end, because this is how these would go on two to the same bar. So it looks like we might be this one over just a tad, and then this one. Yeah, it looks might be a nad's wing too thick on these. It's not too difficult to adjust, and there will be a final part of this tutorial before we start putting the car together, where I actually come in and we do some precision measurements on our bricks and make sure they're all the right size, because once we start moving them around and snapping them, it will behoove us to have the measurements we've done from reference are not very precise, so we're going to get more precise measurements, and then we might end up expanding some of these bricks or contracting them ever so slightly, which again is a very simple thing to do after the fact. Okay, I'm now going to close this Maya file and bring in another one to show you a very complicated brick before we move on to the next part. So here is a much more complicated example of a brick that was actually in this kit. Now this is the most complicated brick in the kit, and because of this single brick, it's all one contiguous piece, as you can see, got extremely complicated. I mean, it's something I would sit down and probably take a day to model. It's much more in advance of the other pieces. So we've actually split this individual brick out into its own 4-hour tutorial for a more intermediate modeling. Because if you're watching this as a very beginner in Maya, modeling something like this is not trivial. It's actually quite difficult. So we've split this out into an intermediate modeling course in Maya, and we will continue our tutorial with the wheel, and then we'll put the car together. Now you don't have to watch the intermediate course. This brick, the one I've done here, will be included in the scene files, so we can go ahead and put the car together. It's just right to take you from what we've been doing to this is a bit of a step up. As I say, this was 4 hours by itself, so it's been split up into an intermediate tutorial, which if you're interested in and you're on our streaming platform, of course, you can just go and watch now before you continue with the rest of this tutorial. Or if you'd rather stick with a more simplified pieces, just until you get your eye in, so to speak, and you don't want to spend an entire day on something like this or an entire couple of days on a piece that's this complicated, then by all means simply use mine. So I'll see you in the next part when we will look at building the wheel. Thank you for watching. Hi, welcome back. So in this part we're going to take a look at building this wheel here, and if we dip into the top view, you'll see I've brought the reference in already. Of course, we've done that enough times now, I think, but we need to make this wheel with some of these holes in it. So we need to make the spokes. So if we count them round, there's actually 8 of them, and then these holes are twice the width of these spokes. So if we did 16 radius divisions on a cylinder, we would get the same size holes as spokes, but if we did 24 radius divisions, we should get the size about right. So I'm going to pull it up to here, like so. Okay, and now we can start to do our radius divisions. If we set this to 24, you'll see that kind of makes sense. So, whoops, I set that to 14. 24. So spoke, double hole, spoke, double for the hole, spoke, double for the hole. So let's do this in a quarter. So let's select the faces here and come on down and delete this half, let's say, and then we'll delete this half. Okay, so we're just working on a quarter, so we don't have to cut in any ultra long edge loops. Let's go to the modeling toolkit and start cutting some edge loops. So let's cut this one first. So about 85%, I would say. Okay, and then enter to finish that loop, and then let's cut up here to about 75%, as close as you can to the reference. I mean, it's not critical. Done. And here, so if we lock it, that's about 50%. So let's cut all the way around, and for some reason it's not letting me. I'm going to start that one again. So Control Z, and up here, what did we say? 50%. Yeah, let's cut again. Okay, it's really not allowing me to do this. I'm obviously cutting on the wrong vertex because we've got X-ray on. I must be hitting one of these bottom verts through the model. So I'm going to turn off X-ray, so I can't do that by accident. Now that technically shouldn't happen, but welcome to the wonderful world of Maya. So 75, 75, 75, 75, 75, 75, and 75. And again here. So enter to finish the tool. I thought it'd start to happen again then. It has. Okay, there's something gone seriously wonky with this already. Now I'm not sure what it is, but we can troubleshoot a bit. we can basically come in here, and I'm going to select these vertices down here, and I'm going to see if there's one that's out, and there is. That's normally the key. So I've gone at some point with that multi-cut tool and accidentally put a vertex down here, and now that's the one it wants to select. So if you run into those sort of problems, they're normally quite easy to sort out. They can be a little frustrating though. So 50, yeah, there we go. So just a vertex that had got accidentally put on the bottom of the model. Okay, pain in the backside, but there we go. So we can start our other cut about 50, 45, I would say. Now these are, whoops, I get that one at 40. These are easy enough to change later on. So, you know, if you've come back and there's been a bit of an error, that's not such a huge issue. Okay, enter to finish that loop and turn on the X-ray. And now we can see we can just cut a hole here, 2 holes here, and a hole here, and we will be good. So let's come in and let's get this done. So face, 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 done, 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 done. And that forms the basis of our wheel spokes. So hole, hole, spoke, 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 so on and so forth. Now I'm going to bring up the bottom just a little bit so we're not, you know, dealing with this massively fat tire here. Okay, a little bit more maybe. So it's like so. And then what we're going to have to do now is this is going to form the back part of the wheel because they're different, which makes this whole thing quite a bit trickier. So let's mirror this first. So mesh mirror, check our pivot point first off. It should be in the center of the object. So let's hit insert, hit W to move, I, insert, and align this somewhere in the middle. So that vertex point right there will do. Q, mesh mirror. Okay, watch your merge threshold, it's way too high. 0.02 should do it in this case. So that seems to be fine. Check the back of the object, that also seems to be fine. So object mode. Okay, now we need to mirror it again, so let's delete the history. So edit, that's edit, delete by type, history, and let's mirror once more, this time in Z. So let's get the axis right, Z, and again watch your merge threshold. You see all this has collapsed and gone bonkers. 0.02 should be absolutely fine for something like this. There we go. And now we want to extrude all of this top geometry upwards. So we're actually going to not extrude it all. Let's have a look at the reference for a second, because this is on an indentation. So let's grab these faces, these faces, these faces, and these faces. Now let's make sure we haven't grabbed any on the back or any of the sides. We haven't. Extrude. Let's extrude upwards like so. These spokes are actually quite thin on the Lego model. So they are kind of like so. Okay, so that should do it for that extrusion operation. Just click away so we've cleared it. And then around the outside is a lip for the tire. So let's extrude upwards and give that a little lip. Again, divisions 1 because we want to keep our geometry nice and neat. And that is basically the Lego tire, the Lego wheel, not the Lego tire, sorry. And now we have to put the back of this thing on. So let's change the reference to the back image. Let's go to the attribute editor and change to the back. There we go, and you can see the back in there. Now we're going to move this above because we're going to be looking at it from the bottom camera now. So let's look at this from the bottom camera, panels, perspective, where do we want to go here, orthographic, bottom. Now we can see it from the bottom. Let's turn off the X-ray so we can see that this hole cut here is in the same location as is on the front, and this rim of course is in the same place. So let's go shading, X-ray off. Now that's going to give us a bit of an issue because now we can't see through to our image plane. Let me turn the grid off here because that's just getting in the way. And let me move this image plane so it goes down a bit. Okay, so yeah, we're going to have to do this with the X-ray on. So shading X-ray, which is going to be a bit more confusing. So we're going to select the top, or the bottom in this case, and in this case I'm just going to make this a circular hole. So really I want to just cut along the same guide. So let's go to the modeling toolkit, multi-cut, and I'm going to cut in here 35% to start the hole, 35, 35, 35. Now I know it's not completely circular, but I don't want to get into too much detailing with this. It's a very small tire, so I'm just going to make mine a bit simpler than the reference. There are Lego wheels that are just round holes like this, so it's not like you can look at it and say, oh, that's not Lego. It's just a little simpler here. And close it up. Done. So we're going to need the lip in the same place as well. So on this, that would be 85, it looks like, or near enough. I mean, you can easily do this with X-ray. The reason I was trying to turn it off there is, you know, when you're looking at this on a tutorial, it's a bit easier to see if you don't have that X-ray switched on. But, you know, easy enough. We're just cutting space for the lip here. Whoops. There we go. And close it, please. Thank you. Right, so we need one more here. So I think at about 25%. Now, if you did want to get the more square look on the reference, you could have, of course, just matched these verts up exactly to it, but I don't think it's necessary with such a small part. And we've gone through a lot of modeling in this tutorial, so I'm sure you can take your time at home and maybe cut it out a bit more precisely. But on screen right now, I don't want to make you guys wait too long until we can see our finished wheel. So there we go. And now I can turn off X-ray, and you can see what we've cut. So let's have a look at this in the perspective view. Let's just drag this reference out of the way now because we don't need it. In fact, let's just turn it off. So object mode, so we've got a front, grid off, and a back. Now the back is basically just a hole in the middle where the axle would go. So in order to do that, we'll select these like so, these like so, and these like so. And actually what wants to come up on the back? Let me just look at the reference again. I'm having a brain moment. So on the back is a hole. Okay, so this is actually indented as well on the back. I thought there was something that wasn't looking quite right about that. So for this extrusion, you want this one, and we're going to just extrude these outwards. Now it's the back where most of the thickness is in this tire. So modeling toolkit and extrude. Let's make it a central extrusion and make sure we're in the right axis here. And like so. And this would be where the axle went on the wheel. So let's get divisions down to 1, object mode, and now we have different sides to this. So let's smooth it. Okay, that's gone, bonkers here because we need some smoothing control edges around. So let's come in and do that. So one here, one here, one here, one here, one here, of course. Now we need to cut one in there, which we will do in a second. Let's just get the easy ones done first. So here, and on the outside, here, here, here. So let's have a look at that. That's holding together a bit better, isn't it? So let's come in, and we really want to cut one around here. around this bottom circle. So come in with your multi-cut tool, and around 95%, we want a nice sharp edge on the bottom of this thing. Now we could remove every other edge here to get back to quadratic geometry, but you know, this cylinder is not going to deform, so again, I'm not going to worry about it too much right now. And of course didn't close when I clicked it, so there we go. So if we did want to go, or we did need to go back to quadratic topology here, it's never a bad idea. Let's just do it right quick. So every second edge you can see I'm selecting, and I believe we have done this before in this tutorial, delete edge, and we should be back to quadratic topology. In fact we are. Okay, so in the case of a cylinder like this, it's not terribly important. These are all quads already, so let's select every second edge around here. So 1, 1, 2, 1, like so. And delete, and we are once again back as a quad. 1, 2, 3, 4. Okay, so nice and simple. Right, let's smooth this and see. We're looking wheel here, wheel here. Now this looks black in the middle, but that's absolutely fine. That will render up just fine. You know, if this was translucent, we might do it a different way, but it's not, so it doesn't really matter. Let's make sure here. Okay. One of the things we've got is no back faces on any of these. So we could actually close them if we wanted to, you know, between the sprockets here. So what you would need to do is come in and grab, let's say, edge number 1 and edge number 2 and bridge, and you'll see that's actually closed up the back of that, like so. So you can go around and do that. In fact, we'll do that now. You'll see it makes a bit of a difference when it's smoothed. Not a huge amount, but a bit. And we should have a back on those anyway. So let's just go around and do it for all of them. Edge, edge, bridge, edge, edge, bridge. And in fact, let's see what we've got in terms of topology in here. Okay, so it's not bad. Just to close the gaps on those sprockets. So now I can't remember which ones I've done, of course. Did I do this one? Yes, yes I did. How about this one? Okay, where am I? Stuck somewhere in the model here. Okay, yeah, that one appears to be done. So I'm going to keep going round, and there should only be 8 of them to do, so it's not too much of a hardship. Okay, this one and this one, bridge, this one and this one, bridge, this one and this one, bridge. We've already done that one. This one and this one, so we've probably done this one. Yeah, we've done them all. Right, select the faces in the center, because this is actually an extrusion as well. This is actually sitting proud of the surface. So extrude up just a little bit, and division 0, done with that. Okay, so there is our wheel without tire. So we'll look at the tire now. So there we go, and there we go, and we are definitely going to need some smoothing control around here, almost certainly. So let's cut some smoothing, let's cut some smoothing, let's cut some smoothing, just to control that smooth. There we are. Probably going to need some around here as well, possibly around here and here, and maybe even around these sprockets on this kind of level. So again, easier to work on a quarter, but this kind of thing, you know, for me, especially when I'm doing this like now as a demonstration, it's very quick to cut these edges in, and it saves having to continuously go backwards and forwards, chop the model in half, mirror it and whatnot. You could also use symmetry up here, which sometimes is going to work for you, sometimes not, depending on what it is you're doing. But let's check the smoothing of this. That's looking much better. Let's just click off, and that's looking pretty good. Quite happy with that. Now, we've got a bit of a problem with the smooth line around there, and that's because we have no smoothing edges here or here. There we go, or indeed here or here. So, let's have a look. Yeah, that's not bad. That looks pretty par on for the original Lego wheel, to be honest, as that is what our original Lego wheel looks like. Now I'm going to do a smoothing hold here as well, all the way around the outside, along with, you could possibly even do one through the center of each of these. So again, it depends on the look you're going for, on how well you want those edges to hold. You can get some quite severe pinching and distortion if you don't have enough edges to hold your smoothing. I think we would have gotten away with what we had, to be frank, but take the extra time and see. I can always take these loops out if I don't like them. And how are we doing now? Oh yeah, that's looking pretty nifty. Okay, I am actually quite happy with that. Now, these don't appear to be perfectly round here, and that kind of gets me. So, in order to combat that a little bit, I'm going to make a double lip here, select all these, select all these, select all these, and then extrude them just a little bit. So it looks like these are actually not one piece, but you know, this is a little thicker. So extrude here, go for a central extrusion, just a little bit. Divisions, 0. Object mode, smooth it, and now it looks like the spokes connect more dramatically to the hubcap, and you know, it appears to be back to completely round again. So yeah, I'm not unhappy with this wheel so far. Let's look at the back of it, and the back of it's looking good. Back of it's looking very plain and simple, but that's the part that would end up, you know, affixing to the axle on the Lego car. So the front and back are dramatically different in this case, and I'm actually quite happy with that. Now you can tinker around with the smoothing, maybe get it a little more dramatic or a little less dramatic, but for me, I'm just going to put a tire on this thing, which will make it a bit different as well. So let's bring back this, and let's grab it and shove it downwards, because I believe it's on top. Right, now we can change our orthographic view here to top, and let's bring the tire in. So attribute editor, and I've got a tire here. Now the tire is about as simple can be. Tire will just use a poly pipe, scale it up like so, and you know, it's too fat, but not an issue. So I'm going to Control H to hide this. I'm going to select this edge, and then I am going to just scale it like so. And is that giving us any problems with the scale? Yes, it is, because we need to select both edges. So, of course, so scale it like so. Doesn't matter if we get it a bit big. Let's bring our tire, our wheel back in, not our tire, and then we can scale it. So, now, seeing what's happened here, that's not good. Let's grab all these vertex. That was my scaling that did that. I should have just scaled in 2 axes and not 3. Okay, and then let's come in and grab this edge and grab this edge. And this time when we scale, hold Control and scale just on X and Z, which you can do by holding Control and scaling on Y. Now we can scale that in like so till it completely encompasses our wheel, sorry. I don't know why I keep getting those two confused. Now let's scale it. So easier in this view. And we want that to fit exactly nice and neatly on our tyre here. So again, hold, in this case we are just scaling in Y, so we can then just scale in Y. No holding of Control necessary. Okay, and when we smooth that, that'll fit on there just like the wheel will. So it needs some smoothing control edges. And this wheel also, let's just move it for a second, has an indentation running around it. So multi-cut tool, where are we? Multi-cut, here we are. And let us select these faces. In fact, let us select these faces and these faces, and we're going to push these outwards a bit. So we're going to extrude here and centralized extrusion. Click on this to scale, click Control and scale in Y to uniformly scale X and Z, and there we go. And that gives us a little lip that would hold the tyre on. Okay, so we shouldn't need to do anything more than that. That's just a little lip here so we can hold the tyre on. Move the tyre up, and again the tyre is going to need some smoothing of its own, but I'm not going to get it too close to the edge this time. I'm going to do quite a big smoothing. So one here and one here, and then on the inside we'll need one here and one here, so far away from the edge basically. So we get a big smooth, because Lego tyres, you know, they're not very sharp, as you would probably expect. So let's just hide our wheel for a second while we do the inside smooths. So again, big smooths, not too close to the edge, and that still gives us, you know, a nice smooth bearing on the way down. Excuse me, Google notification. I think I just run out of cache. That's probably a good job we are coming near to the end of this part. But anyway, Shift H to bring the wheel back in. Okay, now we're talking. Now it might need to be moved a little bit. Let's get that precisely on the rim. So we want that rim to pop up like so. You know, you want to be able to see it. You want the wheel to be sitting on the rim. And now vertex, let's just get this exactly right for the bottom too. So we want to be able to see that rim. There it is, lovely jubbly. Object mode, done, and done. There is your wheel. One last thing, let's give them names. So this would be the wheel, tyre, grab them both, Control G to group them, modify, center the pivot of the group, call the group, wheel, group, and E to rotate, J to lock the rotation. Let's just stand this thing up straight. There we go. One Lego wheel. Okay, so I really hope you found this interesting. In the next part, we're going to talk about scale. We're going to look at, you know, scaling our objects up so they're all the right size, getting the final bricks in place, and I'm actually going to model some bricks in between these parts. That's not wide enough. We can do that on reference a bit later, but it's just looking a bit thin. So there's a couple more bricks that we haven't tackled yet, but they are simpler bricks. There's one outrageously complicated brick which I think I showed you that's in a separate tutorial, so you can go and watch that if you would like, but it is significantly more difficult than anything we've tackled here. So there is a few simpler bricks as well. So rather than make you watch me go through all that, I'm going to actually just do those between the parts. We'll come back. If there was troublesome bricks, we'll talk about it, but I don't think there will be. So in the next part we'll go on to scale, and we will go on to building finally this car. Thank you so much for watching, and I really hope that's been of interest to you. Cheers. Hi, Welcome back. So in between these parts, since we made the wheel and the tyre in the last part, I've gone ahead and made some of the simple bricks we need to finish up our car. So there really isn't anything that you shouldn't be able to do. It's variations of a theme. The most complicated one was probably this one, and it was made in the same manner as this one and this one, basically. So I didn't want to put you through a bunch of redundant information. The holes in the middle of these here were just made by extruding one of these standard blocks downwards. So all very nice and simple. Now in this part I want to talk a little bit about symmetry and scaling, because we've built all of our bricks off reference and the reference wasn't all the same size. So if we look at this 2 brick and this brick we built, you'll see that they're actually different sizes, and in order to build our car we're going to want them to be the same size. Now a standard 1x1 Lego brick, I think I have one here somewhere, so too many bricks now, but a standard 1x1 Lego brick is 7.8 millimeters by 7.8 millimeters, or actually it's yeah, I think that's the size. I did look it up and it's approximately that. So here's a 1x1 brick. So we could come in and make this 7.8 grid units by 7.8 grid units, but that leaves us with a little bit of a sticky wicket, because that's not a convenient number to work with really. I'd rather work with a nice whole number, 5x5, 10x10, something like that, and as long as it's square it's absolutely fine. Now scaling is an issue in Maya, but not to that extent. So if you have something that should be 7 centimeters and you make it 5 centimeters for simulation, for rendering, that's going to be absolutely fine. What you don't want to do is have something that's supposed to be 7 centimeters and make it 7 meters. That's not going to work at all. But for me, I'm going to pick numbers that make sense, because we're going to have to build a car out of all these bricks. We're going to have to do quite a lot of movement. So if I look at this brick in the top view, let's see, here's one I scaled earlier, by the way. So let's have a look at its dimensions. Now this Lego brick is actually, if we move it up, it's actually 5 high, 1, 2, 3, 4, 5 high, and then it would be 5 wide because it's square. However, for us, we'd be better off we'd be better off with these dimensions than we would with, let's say, 7.6 or 7.8 or whatever it's supposed to be. 7.8, I think. So 5x5 for me is much easier numbers to work with, because if I wanted 2 of these long, then it would be 5x10, 5x15, 5x20. Very easy maths, very easy movement. The other thing, at this dimension, at a 5x5, let's focus in here and here and do an isolate selected selected. So show isolate selected view selected. Whoops. Let me just do that again. At a 5x5, so if we take these as 5 Maya units, in this case centimeters by 5 Maya units, this makes this brick exactly 6 high. 1, 2, 3, 4, 5, 6 high, and the knob on the top is exactly 1 high. So again, very easy to work with. So this would be a standard Lego brick size. Now a Lego plate at this scale works out to be 2 high. So this is a standard Lego plate. Object mode, 5x5 by 2 by 1. Let's duplicate this, and if we need to turn that into a standard Lego plate, we can go 5x5 by 2, 4, 6, because a standard Lego plate, a standard Lego brick is 3 times as tall as the Lego plate without the knob. So if this is exactly 2, with this being 5x5, then this would be exactly 6, with 1 again for the knob, because those don't change sizes depending on whether it's a brick or a plate. So very, very easy now to get our stuff all scaled to each other. So let me take a brick whose scale is way out. Let's say this one that we've made. Okay, let's get this on the top view and move it into the center here. So I'm just going to move this onto the center line. So I'm getting the center line of this object and the center line of this one. Now the center line of this object would actually be here, but we're going to ignore the claw for this, because we know exactly what size this brick should be. And as we built this claw exactly to scale from reference, when we scale this one up to be the right size, the claw on the front of it will automatically be the right size by being virtue of it made in scale, albeit the wrong one from the reference. So what we need is we need to get this 10 units wide. So let's just universally scale until we are at 10 units wide. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now get that as perfect as you can. So let's turn the smooth scaling off. And now we know we're 10. Now we've come in a bit of a problem because this is supposed to be 5 wide. 1, 2, 3, 4, 5, 6. So we're actually a little bit too wide. Let's get it on the center point here. And let's see, 1, 2, 3, 4, 5, and a little bit too wide. Now, if we just grab vertices here and scaled them in until it was 5, we're going to be lopsided. So we need some sort of symmetry. Now, you can either do this by scaling it, cutting it in half, and mirroring it, or, I mean, that's a bit of a pain in the backside to do. Let's go back to object mode. Let's select the symmetry here and go symmetry by topology. Now let's select a line that we want it to be symmetrical with. So if you select this edge, it's going to be symmetrical in this and this axis, and if we selected this edge, it would be symmetrical here to here. So let's select this one. Let's go to vertex mode. When we select these vertex, you'll see these have selected. Let's move it in just a little bit, and let's move it down so it's back on that center line, and we can see here we are just a little bit too small here, but again, no real issue. So vertex, just move them out until they're lined up with the grid. There we go, done. So we know that this bad boy is now exactly to scale, and if I move one of these over that I scaled earlier, you'll see that they fit nice and precisely on top of each other. This will come in very handy later on when we put the car together. So just scale all of these pieces the same way. Now if you don't want to do that, obviously I will have done that in between the parts and saved the file, so you can just use mine. But this is a really nice scale to work with, you know, as opposed to trying to get it 7.6 mil, you know, and use exact Lego dimensions, which for Maya is not going to make that much of a difference. We built to reference, so we know the parts are the right size. Whether we make them 5 centimeters or 7 centimeters in Maya is, again, going to make very little difference. To us, it's going to make them easier to move, by which I mean we're going to have to arrange these parts as you would build a Lego car. So, you know, kind of put them together like this, and then, you know, get them in the right place. And this is going to be a bit tedious, to be honest, because look, you know, and then you'd have to use all 4 views to make sure they were straight. So, you know, again, it becomes a bit tedious if you were going to do this part by part. But because these are 5 by 5 by 2, this becomes quite simple. If I double click the move tool here and I go to snap step and I go to relative and I make it 5, well, that will move exactly 1 Lego unit each time we do this. So all of a sudden, snapping our blocks into place becomes ever so slightly easier. And it's the same if you wanted to snap them on the y-axis. We know these are exactly too high, so we can come up and go like so. Okay, so we can check the height of this brick, which I don't think we actually did. Isolate selected, view selected, and just isolate selected, view selected, so we only have 1 there. And let's have a look. So we can see here the height of this brick is 1, 2, and the knob is 1. Yeah, so we're pretty accurate there. I don't mind some tiny, you know, fraction of a millimeter discrepancy. At the end of the day, it just adds slightly to the random look, gives it a little bit of realism. You know, you don't want too much. You don't want, you know, a tiny bit over the line will be absolutely fine. You don't want to be in a situation where you've got different size bricks, of course. I'm not advocating that. It's just if you're a fraction of a millimeter off, then it should be okay. Alright, so in the next part I'll come back with all of these bricks scaled as they should be, and we are using 5 units by 5 units. So a 4 block like this would be 10 by 10 by 2 if it was a plate block, and if it was a normal block it would be 10 by 10 by 10 by 6. Because these plates are 3 times as small as, let's look at this guy here. These plates are, let's see, show, isolate, selected. Okay, these guys should be exactly too high for the plates. So let's center the pivot on this. I'm not sure what it's doing all the way down there. And we've still got snap on, so let's just turn it off. Where are we? Snap off. Okay, so let's bring this guy to align. So it should be exactly too high, with the knob being exactly 1. Again, I think as I went over, if this was a normal brick, it would be 6 high. So, you know, you can either turn the snap-on to 2 if you're moving plates around, or the snap-on to 6 if you're moving blocks around. Either way, it becomes a little easier to do the math in your head to move the blocks around than if we were using fractions of a number. Alright, so I'll be back when I've resized all these, and we'll look at putting this car together, which I will probably organize the first few bricks and then time-lapse it so you can see where the bricks go. Just even with the snap movement, moving blocks into place is a little tedious, and it could take a while. So really I'll have nothing to talk about while I'm doing that. I'll just literally be moving blocks, but I want you guys to see where all the blocks go, of course, so you can follow along and build the car. So we'll probably time-lapse some of that at a speed where you can see where the blocks go, but it won't be too dull. So I hope you found something in here that was useful to you. Thank you very much for watching. I hope to see you in the final part where we put the car together. Cheers. Hi, welcome back. So in this part we're actually going to put our little Lego car together here. Now I've actually made one change when I was going around and rescaling these things and getting them all to scale, and that's with this guy here that we modeled in one of the parts. Now this guy had a few triangles on him here. It really wasn't an issue. I just noticed them as I was cleaning up, so I just put an edge loop around here and then deleted every second edge like we've done many times before to get that into quadded geometry. In this case it would have actually been fine to stay with the triangles around there, as there's no deformation on that, but for the sake of consistency, now we've got all quadded geometry throughout every single brick. So this part is going to be basically me putting the car together the same way I would put Lego together, because later on when we come to animate this, you know, maybe explode it outwards into a more technical view, we don't just want the outside of the car, we need all the bricks in the middle. Now because of that, this is actually going to be fairly long-winded as I move these bricks into place, so I will time-lapse it so you'll be able to see where the bricks go. I'll also do an animation which animates in each brick where it should go. I'll make that available at the end of this video. So if you don't want to watch me time-lapse this now, skip to the end 5 minutes of the video and you'll see an animation of the blocks just appearing in place, which will tell you where to put them. But for now I'm just going to start by setting myself up around the middle of the grid. I'm not going to be too concerned about it right now because I'm going to be moving these blocks into place by eye because I don't want them too exact. Now I can use the snapping on the move tool. I think we discussed this, so you can use the snap step of 5 because we are 5 long here, but I'm going to do most of this by hand because I want a kind of unordered look to it. I don't want it to be absolutely perfect. I want it to look like, you know, someone's put Lego together, haven't quite perhaps compressed all the bricks well enough and whatnot. So now we'll follow time-lapse of me putting this together. So I will speak to you in a minute. I'll come back when I've put the first third of the car together and do a little spin round and then second third and third third. But for right now we're going to time-lapse. Okay, so that's the back third of the car done. This car's actually built in 3 sections. So this is the first section. We're going to now look at building the second section, and as I've said, if time-lapse is not really your thing, you can jump straight to the end of this file and watch the quick animated version. I think it takes about 10 seconds, so you can just scroll through the timeline here, hit the playback, and see where all the parts go. I'm just leaving this in because I know some people will enjoy it, so I'm going to go to the second third of the car now. Okay, so here is the middle third of the car done. Some ever so slight scaling issues, nothing major. You're going to expect a little bit of tidying up to do. You know, we're talking about very, very small fractions of size here. So yeah, I kind of expected to have to do a tiny bit of scaling, but nothing major at all really. So when we finish these parts of the car, we're just going to Control G for this one and Control G for this one, and we'll call this one middle car and back car. Right, I will continue with the time lapse now and finish the front of the car for you. You might have also noticed that I should have probably said that I'm not actually using these blocks, I'm rather Control D to duplicate them and then moving them out, so I've always got a set of original blocks if I decide to build anything else. So I shall now build the front of the car and we'll put the three halves together. Okay, so there is all three halves of our car. All that remains is to group this one, center its pivot, so modify center pivot, and call it front car. There we go. So now we've got front car, back car, middle car. Now we've been left with a load of empty group nodes here, so it's good practice to get rid of those. And these are all our original blocks under finished bricks. So I'm actually going to grab the car group here and middle mouse drag it out of the finished blocks group, and then I end up with finished blocks, which now of course can be hidden. I can export them, use them for something else, you know, making a different car, whatnot. And car front, car back, make sure its pivot is centered, so modify center pivot, and car middle, and again center the pivot, modify center pivot. And now I can simply put the back and front half of the car together. So again, make sure that goes in nice and tight. Now we look a little out on the height here. I'm quite sure how we manage that, but not a huge deal. There we go. And that's pretty much spot on, I think. This one could use a little forward motion. There we go. Done. It's going to be a bit of adjustment when you weld the halves together, but it shouldn't be too bad. So it's back of the car, and that should just plug in like so. This one also might be a little out in the height then. Probably what happened is I had the height of the middle slightly out. That seems to be what happened, and the front and back would have been perfectly aligned to each other because I started out with the axle block that I duplicated from there. So let's have a look at that. And we have little Lego sports car. Look at that. Oops. Let's grab this guy and put him on the floor where he belongs, like so. Done. There we go. Little Lego sports car, and not the way it's normally done, which is to cheat and create a very simple outer shape. We've actually modeled all of the blocks for this, both internal and external, which will make it a lot funnier to work with later on when we can start to animate with it and you know, do exploded diagram views and stop motion kind of building animation. Which brings me to the end of this tutorial. I'm now going to whip up a stop motion Lego animation with this. So realistically I'll just hide and show bricks so it looks like we're building it up, and this will be a very easy way for you to come along and see which brick goes where in this build. So if you skip through the time lapse, no problem. I left it in because I knew some people really do like to see this thing in time lapse and some of you don't, so I'm going to do the animation as well. So I'll be back in a minute with that, and then we'll be calling this first part of this introduction to Maya done. So I hope you learned something, and I'll see you in a second. Okay, so I've done a quick time lapse of this animation going together, as I said I would. I'll also make this available as a separate file called build time lapse or build animation, which I'll play blast from the viewport. But for those of you that have just skipped to the end to avoid that that time lapse bit in this video, I'll just play this through a couple of times so you can see where the bricks go. Obviously you might need to pause the video, but this is basically the setup for the bricks. So for those of you wondering how this was done, this was simply keyframe the visibility of individual pieces of geometry. So after I'd built the car, I went in and hid it all, and then I came back and quite simply showed one bit at a time, keyframed it, moved 5 frames, showed the next bit, keyframed it, and moved 5 frames, and that left me with this build animation. It's kind of a nice way to show your Lego builds off. And again, I hope this has been of interest to you. I will save this out as a separate file as well in case you missed the end of this part because you skipped the time lapse, but that's pretty much all there is to it. I'll be back in volume 2 with a more complex brick, and then we'll start to look at shading, lighting, rendering, dynamics, UVing and other topics within Maya. So very much hope you've enjoyed this, and thank you for watching.